Hello students, so welcome to the class. How are you? I hope your preparations are going well. So today will be the day 11 of our JEE 40 days crash course. Everyone please join the class quickly. We will begin our class in few minutes. And if you have a doubt in the previous class for the solution chapter, then you can ask it here. Please join the class quickly. We will begin in few minutes. So we have covered the first four chapters, including some basic concepts of chemistry. Then we have also covered the chapter thermodynamics, thermochemistry of physical chemistry, and then we have also covered this chemical bonding and molecular structure. We are done with the first part of the solution chapter, and today we will see the second part of the solution chapter, in which we will study the colligative properties. So this will be an important lecture regarding the solutions chapter. I will suggest all of you to please look upon this chapter, because this is something which is very short and marks giving in your JEE exams. So please join the class, comment it here if you are there, so we can begin our class. So anyone you have a doubt of tomorrow, yesterday's class, you can push it here in the comment section. Okay, so we shall now begin our class. So first of all, this is our disclaimer, and what are the topics that we are going to cover today. So there is a small topic which is related to ideal and non-ideal solutions, which is azeotropes. So there are basically two types of azeotropes: minimum boiling and maximum boiling azeotropes. Then we will move on to Henry's law. We have talked the relation about this Henry's law in the yesterday's class. I will now discuss it in detail today. Then after, we will move on to a relationship between the Raoult's law and the Henry's law. So it is a very important point where we will see that how Raoult's law is a special case of Henry's law. Then after, we will begin our colligative property. So this would be the most important part, I would say. Now, what are the colligative properties that we will see? So first of all, we will see the relative lowering of vapor pressure. Then after, we will move on to the elevation in boiling point. Third one is our depression in freezing point, and fourth one is our osmosis and osmotic pressure. So these are the important colligative properties about which we will discuss today. So please send a hi if you are attending the class, so that I can get the names of those who are attending the class. Next, moving on to abnormal molar mass and Vent off factor. So we will see how the molar mass calculation from this colligative property gives us a different result from the actual value, and then we will try to quantify the same with the help of Ventov factor, which is I. And lastly, we will see the modified expressions for this colligative property. So please join the class quickly. We will be beginning our first topic, which is your azeotropes. So Partham, VK Sharma, Dhruv are all are just attending the class. So please comment hi in the comment section. So now we will begin with our first topic, which is azeotropes. Now what are azeotropes? When a mixture of two liquid boils at a constant temperature and its composition does not change during distillation, then such mixtures are called azeotropes, and there are two types. First one is minimum boiling azeotropes. What are minimum boiling azeotropes? So these are formed when the liquid pairs show positive deviation. So we have learnt about this positive deviation in the previous class, where we said that those which show a greater value than the calculated value from the Raoult's law are termed to be known as showing the positive deviation. What are the example of positive deviations which are coming under your minimum boiling azeotropes? So first one is ethanol plus water, then we have ether plus acetone and water methanol. So these are some examples of azeotropes which shows minimum boiling azeotropes. Moving on to the next. What is the next one? Maximum boiling azeotropes. So these are formed by those liquid pairs which show negative deviation. So opposite of your minimum boiling azeotropes, we have our maximum boiling azeotropes. What are the examples of maximum boiling azeotropes? So we have water plus hydrochloric acid, where the percentage mass of water is taken as 20.22%. Similarly, we have acetone plus chloroform, and we have water plus nitric acid. So anyone who is facing difficulty in understanding what is azeotropes and what are the types of minimum boiling, what are the types of azeotropes? Anyone who has a doubt in this? So please comment it here if you are having any doubt regarding this azeotropes, because I have seen one question in the PYQs regarding this same topic. So do you have a doubt from ideal or non-ideal solution which we were discussed yesterday? So from there, this is explained your positive deviation and negative deviation. So if you are not clear about that part, which is our non-ideal solution, then you will face difficulty in this minimum boiling azeotropes and in maximum boiling azeotropes. Okay, so I hope you are getting my point. Now moving on further to the Henry's law. So we talked about Henry's law yesterday. It is related to gases in a gases as a solute which is present in the liquid solvent. Okay, so for those kind of solutions we have this Henry's law. What does it say? It states that if the temperature is constant, then the solubility of a gas in liquid is directly proportional to the partial pressure of that gas above the surface of the liquid or solution. Meaning, higher the partial pressure of the gas, the more gas will be dissolved in the liquid. Okay, so suppose you have a liquid surface, right, and you are putting gas above it, then the pressure that is applied on the liquid surface decides that how much gas will be dissolved in the liquid. If you apply more pressure of the gas, then more and more gas will be dissolved in your liquid state or in the solution form. Now we can write it in mathematical form also, that partial pressure of your gas is directly proportional to your mole fraction. So here we are taking your mole fraction as the concentration term. Okay, so we know that if we increase the pressure of the gas above the liquid, then more and more gas will be dissolved in your liquid. The most simple example of it would be your carbonated drinks, where the carbon dioxide is pushed into the liquid solution by applying more pressure. You can simply imagine this, or you can simply see this when you open the lid of the cold drinks and you see that the fizz is coming out, right? The solution becomes fizzy, and that bubble that you are seeing is your carbon dioxide, your dissolved carbon dioxide, which was put into the liquid under high pressure. Got it? As soon as you remove the lid, the pressure decreases, and due to the decreased pressure, the gas molecules come out of your liquid solution. So we can say that the more pressure you applied on the liquid surface through the gas, the more gas is dissolved in your liquid solution. And to represent the amount of gas present in that liquid, we use the concentration term chi, which is your mole fraction of the gas. Now we can just write it mathematically here. So P is directly proportional to chi. Now to remove the proportionality constant, we are introducing a constant known as Kh. This Kh is what? This Kh is your Henry's constant, Henry's law constant, and this Kh is defined for solvent only. Now, can you say what will be the effect of higher Kh value? Yeah, it's very simple. If you just rearrange this equation, you will get Kh is equals to P by chi. Okay, so we can say that Kh is inversely proportional to chi. More is the value of Kh, less is the value of chi. And chi is what? Chi is representing your concentration. So if you are increasing the value of Kh, you are decreasing the concentration, means Kh reduces the solubility of your solute in the solvent. Okay, so this is very, very important to understand. And then moving on to the next part, which is the most important part, I would say, related to Henry's law and Raoult's law, is that the relationship between your Raoult's law and Henry's law. It is seen that your Raoult's law is nothing but an extension of your Henry's law, or a different version of your Henry's law. Let us see how. To understand this, first let us write what is Henry's law. So what is Raoult's law? We studied in the previous class that Raoult's law gives that your partial pressure of the gas or of the liquid is directly proportional to the pressure of the pure liquid. So this is your Henry's law statement. Got it? So Pi is equals to chi Pi naught. Then next, from the Henry's law we studied today that the pressure of the gas is equals to the Kh chi. Again, chi is the concentration. Now if you compare both this equation, I mean this equation and this equation, what we can say? We can say that only one thing is different. We have the same mole fraction in both of them. The pressure is present in both of them. Only the proportionality constant is different. In the case of volatile components, or in the case of Raoult's law, we take P naught I, where P naught I is the pressure of the pure solvent. And here we have Kh, which is your Henry constant. So from this, we can say that your Raoult's law is a special case of your Henry's law, where your Henry's constant is equals to the pressure of the pure solvent, isn't it? So we can say that Kh is equals to P naught I in case of liquid component. Okay, is it clear to you? Any doubt in this part? Anyone who has a doubt in this part? What did I say? So we have first seen that what is your Raoult's law. Your Raoult's law says that Pi is equals to Ki Pi naught. Similarly, your Henry's law says that P is equals to Kh chi. Okay, or you can also write it as Pi is equals to Kh chi I. Now your Henry's law is applicable to gas dissolving in liquid, and your Raoult's law is applicable to liquid dissolving in liquid. Got it? So whenever we are changing the phase, we are seeing that the proportionality constant is changing. So here it was Kh, and now that Henry's constant has turned into your P naught I, which is the pressure of your pure solvent. So anyone who has a doubt till this part? Okay, so if you have a doubt, you can just post it here in the comment section. So please comment here so I can get a view of how many of you are attending the lecture. If you got it, please send a thumbs up, and if you're having any doubt, then you can send it on the comment section. Okay, so is it clear to you? Henry's law and Raoult's law as a special case of Henry's law. So next we will move on to colligative properties, which is the most important part of your solutions chapter. Now, water colligative property. So these are those properties which depend upon the number of particles, okay? The number of solid particles that you are dissolving. And it is not dependent upon the nature of the particle. So this is the most important point you should remember. Water colligative properties, the properties which depend only on the number of the solid particle and not on the nature of the solid particle. Got it? Now, to define it further, we have some examples. First one is relative lowering of vapor pressure. So, can you tell me the formula for relative lowering of vapor pressure? How do I represent it mathematically? We have talked about this. Remember? P naught minus Ps by S. Okay? So, we have seen this thing that you can represent mathematically the relative lowering of vapor pressure as P naught minus Ps by Ps, where P naught is the pressure of the pure solvent, Ps is the pressure of your solution phase. Got it? Then we have depression in freezing point, elevation in boiling point, and osmotic pressure. So these are the four colligative properties that we are going to cover today. So the most important point that you should remember is that colligative properties only depend upon the number of solid particle and not on their nature. So basically it is mainly applicable to non-electrolytic system. We will see an extension of this for electrolytic system as well when we will study the abnormal molar mass. Next, for different solutions of same molar concentration of different non-electrolyte solutes, the colligative property have the same value. Okay, so what is the meaning of this? That if you are taking suppose three different types of non-electrolyte solute, suppose one you are taking it as C2H5OH, which is a non-electrolyte, that is ethanol. Then second you are taking your glucose C6H12O6, and third thing you are taking your sucrose, which is C12H22O11. So these are three electrolytes, non-electrolyte solutes, and if you keep three different solutions and in all of them three you are keeping the same molar concentration, means the nature is different because the three compounds are different, but since your molar concentration is same in all the solutions, as a result of that the colligative property will have the same value. So this is the physical meaning of the definition. It is very important to understand that until and unless you are not changing the molar concentration, you will not get a different value if you are taking non-electrolytes. Okay, any non-electrolyte you take. Non-electrolyte means those who do not conduct electricity or those who are not broken into ions upon dissolving it into aqueous solution. Next is for different molar concentration of the same solute. So if you are taking the same solute in two different solutions but you are changing the concentration in both of them, then you will observe that the colligative properties have a different value. The one with a higher concentration will show a greater value of the colligative property. So this is important to note here. First point that I have said it that if you are keeping the same molar concentration of different non-electrolytes, then in that case the colligative property will have the same value. But in place of that, if you take a different concentration but the same solute, in that case the colligative properties will show a different value and the one with the higher concentration will have a greater value. Is it clear to all of you? Next, for solutions of different solutes having same percentage strength, the colligative property has greater value for solute having least molecular weight. So this is defined for what? This is defined for your percentage strength. So this is for molar concentration, which is your molarity. Then this is for your percentage strength. So if you are keeping the same percentage strength, you are taking two different solutes, okay, and you are taking the same percentage strength, then in that case your colligative property will depend upon the molecular weight. Got it? And if the molecular weight is greater for one of those, then the one with the greater value will show a higher value of the colligative property. Why is it so? So if you are having the least value of your molecular weight, that means the number of moles will be more, because you know that number of moles is directly proportional to weight and inversely proportional to your molar mass. So if you are increasing the molar mass, you are decreasing the number of moles, and number of moles is simply the number of particle. Therefore, if you are having a less molecular weight, then you will have a greater number of particles. As a result of that, it will have higher colligative property. So I am telling it for those solutions which have the same percentage strength. Is it clear to all of you? So this is the basis. If you got these 5 points clearly, then and then only you will able to understand all the colligative properties and solve all the numericals. Any doubt till this 6 points, this 5 points? Please comment it here if you have a doubt. And if you have no doubt, then please comment it here that you got the point. Okay. So that will help me to know that whether you are involved in this lecture or not. Anyone who has a doubt in this part? Is it clear to all of you? So what are the 5 points that we discussed today? First, that colligative property depend upon the number of particle and not the nature. And what are the examples? Relative lowering of vapor pressure. So it is also written as RLVP, the pressure in freezing point, elevation in boiling point, and osmotic pressure. Then it is seen that for different solutions of same molar concentration of different non-electrolytic solution, the colligative property have the same value. But if you are taking the same solute, but you are changing the concentration, in that case, one with the greater value of concentration will have the higher value of colligative property. And the third point, if you are keeping the percentage strength same, then in that case, the colligative property will depend upon the molecular weight. The one with the lower molecular weight will have a higher value of colligative property, because number of moles is directly proportional to number of particles and inversely proportional to your molecular weight. I hope you get my point. Now, moving on to the next, our first colligative property, which is relative lowering of vapor pressure. Now, the basic, I would say, condition to apply all this colligative property, not only for this, is that you are putting a solute which is non-volatile in nature and a non-electrolyte as well. What did I say? Your solute should be non-volatile as well as non-electrolyte. Means on going into the solution, it should not dissociate as well as it should not go into the vapor phase. Got it? So these are the two important points that you should remember while applying the normal colligative property. For electrolytic system, which are not non-electrolytes, for those we have a different set of formula. We will look upon to that. Got it? And for volatile solution, it is not applicable at all. Okay, so 2 points are there. The formulas that you are going to see are applicable to non-volatile solute and non-electrolyte solute. But if you want a formula for electrolyte one, then you have to move upon to the latter part of our lecture, where we will see it for the electrolytes. But for volatile solute, the second difficulty is not being solved here. Okay. Now, what are volatile solute? To know it very well, these are those solutes which have a lower boiling point or that goes into the vapor phase in the easier way. So, if I try to just write the formula for relative lowering of vapor pressure, then you know how to formulate it mathematically. P naught minus P. So we have talked about this. See, this is discussed in the previous class. So P naught minus P by P naught. This is our relative lowering, because this P naught minus P is representing our lowering, and when we divide it with P naught, it depicts the relative lowering. And this thing is equals to the mole fraction of the solute. Okay. Next, if you just write it in a different way, you can write it here as P naught minus P by P naught is equals to NB by NA. You will ask me how we are saying this, because if you write the mole fraction of solute, then it should be NB by NA plus NB, means the total number of particles should be in the denominator. But here we are only having the solvent, which is Na. The reason is that these colligative properties are applicable to dilute solutions where the concentration is not that much high. If that is true, then in that case your solute count is very, very small as compared to the solvent count, and hence we ignore the solute count. So Na plus Nb is approximately equal to Na, which is your number of solvent particles. Now here P naught is what? It is the vapor pressure of the pure solvent. Then P naught minus P by P naught is your relative lowering. We talked about this. And your NB and Na are the number of moles of solute and the number of moles of solvent respectively. Got it? And as I said earlier, so if you just expand this chi solute, it will be Nb by Na plus Nb. But since Na is much more greater than Nb, so we are writing Na plus Nb as simply Na. Is it clear to all of you? Any doubt till this point? Anyone who is facing difficulty in this? So this is our first colligative property. If you have a doubt, then please comment it down in the comment section. Okay, so I hope this is clear to all of you. Anyone who has a doubt in this? So we will move on to the next one, which is the determination of molecular mass from this relative lowering. So we will try to determine the molecular mass of the solute. Remember, we have to determine the molecular mass of the solute using the formula of the relative lowering of vapor pressure. How do we do it? So to do that, we will simply expand our previous formula. What was our previous formula? It was P naught minus P by P naught is equals to NB by Na. Okay. Further, if you write in place of NB, WB by MB, which is your number of moles given as weight of B divided by molar mass of B. Similarly, for Na, we can write it as WA by Ma. If you rearrange that, we can get MB is equals to WB into Ma by WA into P naught minus P by P naught. You can just try it again by yourself. Just please note it down and try it by yourself whether you're getting the point or not. Are you getting the same formula upon the expansion of the previous one? What was the previous formula? It was P naught minus P by P naught is equals to NB by Na. Then if you just write in place of NB, WB by MB, where WB is the weight of the B and MB is the weight of the molar mass of the B. Similarly, you can write it for A. So after doing that, are you getting this formula for after rearranging for MB? Anyone? Just try it by yourself. So for DPPs and test, you can just refer to our website. From there, you can just attend our DPPs related to this same topic that I am discussing today. And apart from this, you can also have a mock test, which is a combination of 4 chapters that we have already learnt in our previous class. Okay, so anyone who got the actual equation that I am seeing here from the previous formula that we have seen for the relative lowering of vapor pressure? So did you get the same formula? You have to simply rearrange our previous formula, which was P naught minus P by P naught is equals to NB by Na. Then you have to substitute NB as WB by MB, which is our simple formula of calculating the number of moles. Similarly, you can substitute it for Na, which is WA by Ma. Then you can rearrange it to get this formula. So anyone who got this formula? Yes. So Varshak got this. Anyone else who got the formula? Okay. So I hope you are getting it. Now moving on to the notations that we used here. So WB and WA are the mass of solute and solvent. Then we have Ma and Mb, capital Ma and capital Mb, which is our molecular weight of solute and solvent respectively. So this is our complete formula for the calculation of number of moles of solute, then the molar mass of solute from the relative lowering of vapor pressure. Okay. Now moving on further. Next we have the elevation in boiling point. So we know that there is a relative lowering of vapor pressure when we are adding a non-volatile solute into a volatile solvent. The vapor pressure of your solution decreases or the solvent decreases. Now what is the reason behind it? The reason is that in the first case where you took the simple solvent, your number of solvent on the surface was more. Only the solvent particle was present on the surface because you took the pure solvent. And the number of particles exposed to the environment was more. As a result of this, you were getting a higher evaporation. As soon as you add a non-volatile solute into your solution or into the solvent, I would say, some of the area on the top surface is now taken by your non-volatile solute. As a result of this, the exposure of your solvent to the environment has decreased. So the vapor pressure has got down. Okay, so this is the reason behind the lowering of your vapor pressure. Okay, just think about it. It's very simple to understand. Now, next, if it is so, then what is the outcome of this? What is the outcome of the lowering of vapor pressure? So, as a result of this, your boiling point will decrease. Why it will decrease? Because boiling point is simply the going of your solute particles or the solvent particle into the vapor phase. Okay, so the conversion of your liquid into gas. So that is your boiling point. But since your vapor pressure is decreased, therefore the boiling point has increased. You got it? Try to understand it in this way. First of all, you should know what is boiling point. So boiling point is that temperature at which the vapor pressure of your liquid is equals to the atmospheric vapor pressure. So you can think of this as two things pushing together, right? So your atmospheric is supplying some pressure and your solution is supplying pressure from the down. If the pressure from the liquid phase is more, then it will try to get into the atmosphere. Okay, then and then only you will see that the evaporation or the boiling it is taking place. But if you add a non-volatile solute, then the pressure from your solution has decreased due to the non-volatile particles. So you have to now supply more temperature to your solution to go it into the vapor phase. Got it? So this is the basic reason behind your elevation in boiling point. And as a result of this, the boiling point of the solution is always higher than the boiling point of the pure solvent. Then we can simply write the formula for it. It is delta TB is equals to kbm. So more is the number of your solid particle in the solvent, more is your elevation in boiling point. Okay, so to represent the number of particles of solute, we are taking the molality term. Okay, so more is the concentration of the solute, more it is difficult to put your solution particle to go into the vapor phase, or you should say that it will have a higher boiling point. Got it? Now to remove the proportionality constant, we introduce this Kb, which is your ebullioscopic constant or molar elevation constant. And what is delta Tb? It is the amount of elevation, Tb minus T naught B. Here Tb was the boiling point of solution and T naught B is the boiling point of the pure solvent. Now how do you calculate this Kb? So in questions you will see that your Kb value is given. In case it is not given, you can calculate it by using this formula, which is Kb is equals to molar mass of the solvent, which is Ma, R T naught B square by 1000 into delta H vaporization. So here R is the gas constant, then delta H vaporization is the latent heat of vaporization. Next, Kb is the ebullioscopic constant or molar elevation constant, and it will depend upon the solvent only. Is this formula clear to you? So delta H vaporization is the latent heat of vaporization. It means the amount of heat which you should supply to 1 mole of that solvent to be converted into the vapor phase. So that is known as your delta H of vaporization or latent heat of vaporization. R, you know it very well, it is your gas constant 8.314 joule per mole per Kelvin, and T naught B, which is your boiling point of the pure solvent. Is it clear to all of you? Now you will ask me why you are dividing this by 1000. So your molar mass of A, which is your solvent, is present in gram per mole. But all of the things apart from this, like your R, T naught B, delta H vap, all of these are in SI units. So you have to convert this MA into SI unit by dividing it by 1000. So you can get your molar mass in kilogram per mole rather than gram per mole. So is it clear to all of you? Any doubt in this part? So if you have a doubt, you can just comment it in the comment section. And at the same time, if you have some suggestions for us for our current going 40 days crash course, you can just post it here. Now, if I say that the formula for depression in freezing point, which is our next colligative property, is similar to this formula, only rather than writing it as B, we will write it as F. Very simple to learn. What you have to do for depression in freezing point, you have to simply replace this B by F. That means your delta TF is equals to KFM. All things will be similar to the case of your elevation in boiling point. Only in case of depression in freezing point, you have to write it as depression in freezing point, which is delta TF is equals to KFM. Got it? So this is your change that you will see right now in the next upcoming colligative property. And the formula of Kf will also change by a small bit. So here you have to only change the T0B with T0F and your delta H vaporization with delta H fusion. Okay, so that is the change that you will see in the next slide. So moving on to the elevation in boiling point. Okay, before that, let me conclude our elevation in boiling point, by which we can calculate the molecular mass of the solute. So you will see this in every case. Basically, this colligative property is used is to calculate the solute molar mass only. You will, in every case, you will see that I put a formula to calculate the molar mass of the solute. So if you extend your formula in the previous slide that you have seen with MB, WB and WA, you will find that your molar mass of the solute can be calculated by using MB is equals to KB into WB into 1000 by delta TB into WA. So what we have done here, we have expanded the molality. What is molality? Number of moles of solute present per kg of the solvent, right? So this is the mass of solvent, and in place of the number of moles, we have taken the given mass, which is WB by MB. Okay, so we have just expanded our previous formula. Now moving on to the depression in freezing point. So we have seen that upon addition of your a non-volatile solute, first thing that happens is the lowering of the vapor pressure. Second thing that happens is your elevation in the boiling point, and third thing that will occur is your depression in freezing point. That means your freezing point will go even down. So suppose the freezing point of water is 0 degrees Celsius, right? But if you add a non-volatile solute into it, its freezing point will be going even down. It can go to 0 point, or it can go to minus 1 degree Celsius or minus 2 degrees Celsius. So basically it will result in lowering. Okay, so this is the difference between both of them. In case of boiling point, the boiling point increases upon addition of your volatile liquid, a non-volatile solute, and in case of freezing point, the freezing point goes down on addition of your non-volatile solute. Now for dilute solutions, we can write the formula for depression in freezing point as delta TF is equals to KF into M, where delta TF is T0F minus TF. Okay, T0F is what? The actual freezing point of the pure solvent, and TF is the freezing point of the mixture or the solution. Now you should ask that why are we writing T0F minus TF? Because in the case of your boiling point, we have written it as TB minus T0, means the boiling point of the solution minus the boiling point of the solvent. But here we are writing just opposite of that. What? Freezing point of the solvent minus the freezing point of the solution. Okay, so this is the difference between the two formulas. Why we are doing it so? To keep the value as positive, because now we have seen that the freezing point has gone down, and if we subtract TF minus T0F, we will get a negative value. So to keep it positive, we have reversed the places. Next, here T0F is the freezing point of pure solvent, TF is the freezing point of the solution. Then we have Kf, our cryoscopic constant or molar depression constant. Remember to learn the names. Kb was what? Ebullioscopic constant, and here Kf is the cryoscopic constant. They have one more name, Kb as molar elevation constant, and Kf is molar depression constant. Now, next we can write the formula for Kf also. As I have said it earlier, you have to just replace T0B with T0F, and second thing, delta H vaporization with delta H fusion, because here you are, what you are doing, you are turning it into the solid phase, you are not vaporizing it. So therefore you will use delta H fusion. Okay, so that is the only difference which is seen here in the case of your Kf formula. Is it clear to all of you? Anyone who has a doubt in this? So can we move further? So if you have a doubt, you can just ask it in the comment section. So we have already learnt about the relative lowering of vapor pressure, the elevation in boiling point, and the depression in freezing point. So next we will move upon to the osmosis and osmotic pressure. Before that, we will just rearrange this formula to calculate the molar mass of the solute. Now next, determination of molecular mass from the depression in freezing point. So similar to that of the elevation in boiling point and relative lowering of vapor pressure, we can also calculate the molar mass of the solute from depression in freezing point colligative property. So the formula will be Mb is equals to Kf into Wb into 1000 divided by delta Tf into Wa. Here the terminologies are, first one is Mb, which is the molecular mass of the solute. Second one is Wa, which is the given mass of a solvent. Third one is Wb, which is the given mass of the solute. And fourth one is delta Tb, depression in freezing point. And lastly, we have Kf, which is the cryoscopic constant. Okay, again, we have rearranged our previous formula, which was delta Tf is equals to Kfm. So in place of molality, we can write it as number of moles of solute divided by the mass of solvent. So here is your mass of solvent, and number of moles of solute is simply Wb by Mb. If you rearrange that formula, you will get your final formula as Mb is equals to Kf into Wb into 1000 by delta Tf into Wa. Now moving on to our last colligative property, which is osmosis and osmotic pressure. So your osmotic pressure is your colligative property that we are going to discuss today. It is seen that whenever you keep a pure solvent in a container and in the another container you keep the solution, what we are doing, in one container we are keeping the pure solvent and in the other container you are keeping the pure solution. Now you are dividing both of them with a semi-permeable membrane. What is semi-permeable membrane? So semi-permeable membrane is a wall which allows the movement of solvent only and not your solid particle. What did I say? A wall which allows the movement of solvent only and not the solid particle. So if you take such a situation, then what will happen? The solvent molecule will move from the solution phase where your impure solution where your impure solvent is present. So it will move from that container to the other one. Got it? Because your SPM or your wall that I am talking about, your semi-permeable membrane, is allowing only the solvent molecule to pass through. As a result of this, your pure solvent will move from where? From the pure side to the solution side. Okay? You got it? What did I say? That if you are taking your solution in one container, your solvent in the other container, and you are putting a semi-permeable membrane in between, then what will happen? Your solvent particle will move from pure solvent into the solution side. Got it? Now you can, what you can do, you can apply a pressure upon the solution. Okay, as a result of this, the solvent particle will not move from the pure solvent side to the solution side. So again, remember my thing. First, what are we doing? We are taking, on one side we have solution, on another side we have pure solvent, and in between we have a semi-permeable membrane that allows only solvent particle to pass through. In that situation, the pure solvent will move from pure solvent side onto the solution side. Then second thing, what did I say? if you apply some pressure on the solution side, which is known as osmotic pressure, the amount of pressure which you have to apply to stop this spontaneous flow is your osmotic pressure. Is no, then in that case, what will happen? Your movement will stop. Got it? And to calculate that amount of pressure which you have to apply to stop that spontaneous flow is your osmotic pressure, and is given by N by V into RT or CRT. It is simply your molarity. Okay, so this concentration that we have used is your molarity. So here N is the number of moles of solute, C is the molar concentration, V is the volume of solution in liter, R is the gas constant, and T is the temperature in Kelvin. I hope you are getting my point. What I put about this osmosis and osmotic pressure. Okay. Now, moving on further, we'll see the relationship between osmotic pressure and molar mass. So this is the formula that we got. Pi V is equals to nRT, which is coming from pi is equals to CRT. If you take N is equals to given mass by molar mass, then we can substitute the value for the solute, which will be WB by MB, and if you just rearrange it, you will get it as MB is equals to WB RT by pi V. So just put in place of this N WB by MB and rearrange this. WB is equals to what? Sorry, MB is equals to WB RT by pi V. Now, here are some important terms that you should remember. So if two solutions have the same osmotic pressure, in that case you call them as isotonic solution. Iso means same. Okay. Then next, if you take two solutions and if one of them is having a higher osmotic pressure, you call it as hypertonic solution, and the one with a lower osmotic pressure is known as hypotonic solution. Will you remember this? So two things are there. First, if you take two solutions of similar osmotic pressure, you will call that set of solution as isotonic solutions. And if you take two solutions of different osmotic pressure, in that case, one with the higher one is known as hypertonic, and one with the lower one is known as hypotonic. Moving on to the abnormal molar mass. So we have talked about electrolytes, non-electrolytes in our whole discussion. Now we'll move on to those type of solutes which dissociates upon moving into the solvent. For example, we have NaCl. So NaCl is what? It is an electrolyte. As soon as you introduce it into the liquid, it will dissociate into Na plus and Cl minus. So this is an example of electrolyte. So for those, what we see that if we use this colligative property to calculate the molecular mass of the solute, then you will get a value which will be either higher or lower than the calculated value. Now, it will depend upon the situation, whether your molecule that you are introducing into the solution is dissociating or associating. So there may be the chance of association as well. Suppose you take the example of carboxylic acid, suppose. So two carboxylic acid molecule can combine together through hydrogen bonding and form a single entity. So that will be the case of association. So in the case of association, what will happen? The number of particles will decrease. Initially there were two particles. Now they have combined to form one particle. Now go back to our previous and first starting point, where we said that if you are changing the number of particles, then the colligative property will change. And colligative property is directly proportional to the number of particles. But in association, when two particles combine and become one particle, then the number of particles will go down, and as a result of that, the value of colligative property will also go down. Similarly, in case of dissociation, what will happen? Initially, which was one particle, now it is dissociating into a number of particles, and as a result of that, the number of particles has increased, and hence the value of colligative property will also increase. So these are the two aspects you should always remember, and there can be a direct question in your exam regarding your association and dissociation. Okay, can we take the example of association? Yes, I said that when you take two carboxylic acid in a polar solvent, surely they will go and combine together to form a polar cyclic chain. Okay, and that will result in the decrease in number of solid particle, hence decrease in the colligative property. In place of that, if you take NaCl, which is dissociating and increasing the number of particles, because initially suppose if you take 1 mole of NaCl, upon dissolving it into water, there will be now 2 moles of particles, where 1 mole will be of Na plus and 1 mole will be of Cl minus. So as a result of this increase in number of particles, the colligative property will increase. Okay. Now, if this is clear to you, Now we will move on to the Vent off factor. So I will directly discuss the formula, the working formula, which is important for your exam. So this was introduced by Vent off in 1880 to account for the dissociation and association. Now the question is that in some cases the association or dissociation is not completely occurring. For example, if you take weak electrolytes, your acetic acid, which is a kind of dissociating particle, but its dissociation occurs to a certain extent. To address that, where the dissociation has some percentage or the association has some percentage, we have certain working formulas, and those formulas are very, very important. So if I simply define I factor before moving on to that formulas, I factor is the number of particle before association divided by number of particle after association divided by number of particle before association or dissociation. Now if I ask you, can you take example of NaCl? Yes. Before association, the number of particle for NaCl was 1. There was one NaCl molecule present. Now you took that molecule and put it in the water. What will happen? The number of particle will become 2, one Na plus and one Cl minus. So what will be the number of particle after association? It will be 2. Sorry, after dissociation it will be 2, and before dissociation it was 1. So the value of I for NaCl will be 1. Got it? Or you can simply remember it as the number of particle in which your molecule is dissociating. So from that methodology, can you tell me what is the number of particle for a ionic compound AB2? Again I am repeating my question. What is the value of I for an ionic compound AB2? So please comment it down in your comment section. I said it earlier, to calculate the number of particle is simply calculating your I. As simple as that. So can you tell me what is the number of particle if I take an ionic compound AB2 and dissolve it in water? So what will be the value of I in that case? So it's a simple one, so I would expect you to answer it quickly. Remember, ionic compounds are always dissociating to a maximum extent when dissolved in a aqueous solution. Anyone who is willing to answer this? So again I am repeating my question. You have a ionic compound AB2 and you are dissolving it in water. Then you have to calculate the value of I for that AB2. Okay, so let me give it for you. Since it is an ionic compound, so it will completely dissociate into water and form what? 3 particles. Okay, so 2 of B and 1 of A. Therefore, the value of I will be 3 in that case. So you have some more working formulas. I is equals to normal molecular mass by abnormal molecular mass. So normal means the one which you know, okay, which is the actual one, and abnormal means the one which you have calculated. Third formula, I is equals to abnormal or observed colligative property by normal or calculated colligative property. So I am just changing it here from molecular mass to colligative property. So this is the one which you are getting from calculation, but the ratio is reversed here. Okay, so abnormal means the one which you are getting from the calculation, and in the denominator normal we have the one which is the actual one. So this will also give you your I. Is it clear to all of you? Any doubt in these three formulas? Yes. So please comment your doubt if you have a doubt till this point. So next we'll move on to the question part. Okay. So I hope it is clear to all of you. Now next, significance of Vent-Off factor. First, it depends upon the association and dissociation, and it defines it quantitatively to what extent your association or dissociation will occur. Now, if I is greater than 1, that means dissociation is occurring, that your number of particle is increasing. And if I is less than 1, then the number of particle is going down, that means association is taking place. Further, the degree of dissociation can be directly related to I. So alpha is the degree of dissociation, and alpha is equals to I minus 1 by n minus 1. Now there is a important point here. Suppose you are trying to calculate the number of particles for CH3COOH. Okay, so in that case the n value will be 2 and alpha will be the degree of dissociation of that acetic acid. Similarly, for degree of association, it will be alpha is equals to I minus 1 by n minus 1. So there is a small change. In place of n, we will write it as 1 by n. So here n is what? N is the number of particles which are associating in case of degree of association, and n is the number of particles which are dissociating in case of degree of dissociation. Okay, got it? So if this is clear to you, now we can write the modified expression for colligative property which is applicable to those molecules which shows association or dissociation. The first one is the relative lowering of vapor pressure. So what we do is we write the complete formula and we simply multiply I here. Okay. Similarly, for elevation and boiling point, it will be delta Tb is equals to I kbm, where I is the Vent-Off factor, again m is the molality. Then similarly we can write it for freezing point, delta Tf is equals to I kfm, where m is the molality, and third, osmotic pressure pi is equals to I crt. Okay, so these are some important formulas which we will use in case of molecules which are getting associated or dissociated. So this was all for the theory part. Now we will move on to the question part. Just wait for a while. We will move on to the question. So here is your first question. What is the question saying to you? It is telling you that at 100 degrees Celsius, benzene and toluene have vapor pressure of 1375 torr and 558 torr respectively. Now, assuming these two form an ideal binary solution, you have to calculate the mole fraction of benzene in the vapor phase at 1 atm and 100 degrees Celsius. Okay, so it's a very simple one. You have to simply use your relative lowering here. Got it? So just please try to solve it and comment the answer in the comment section. What will be the answer for this question? Please comment it here. So what you are given with? You are given with the partial pressure of your benzene and your partial pressure of your toluene. You have to suppose that this is a ideal binary solution. So in that case, your Raoult's law will be applicable, and further you have to use the Raoult's law to solve this. The total pressure is also mentioned, it is 1 atm. See, it is given that assuming these two form an ideal binary solution, then calculate the mole fraction of benzene in vapor phase at 1 atm. So the total pressure is given as 1 atm here. Okay, let us move on to the correct answer. Anyone who got the answer, please comment it here. Okay, moving on to the correct answer. The correct answer will be C, 0.447. How do you solve it? So, if you suppose that chi1 is the mole fraction of benzene and 1 minus chi1 is the mole fraction of toluene, then we can write the total pressure as chi1 p1 naught 1 minus chi1 p2 naught. How we are writing it? So we know that from Raoult's law, the pressure due to 1, which is your benzene, is chi1 p1 naught, and pressure due to 2, which is your toluene, is chi2 p2 naught. Now in place of chi2, you can write 1 minus chi1. We know that the summation of mole fraction of every component in a given solution is equals to 1. So chi2 plus chi1 is equals to 1. Therefore, chi2 is equals to 1 minus chi1. Now next, just put the values here. The total pressure, as I said, it is 1 atm. But since your partial pressures are given in torr, you have to convert 1 atm into torr. So 1 atm is equals to 760 torr. Then here we put the value of the pressure for the benzene and toluene, which is 1375 and 558. Then after, we calculate the chi1. Okay, just so it is a linear equality with one variable. We can easily solve it. So chi1 will come out to be 760 minus 558 divided by 1375 minus 558. This will give you 0.247 torr. Next, what you have to calculate? You have to calculate the mole fraction of benzene. How you will calculate it? So for that, we will use the formula y1 is equals to chi1 p1 naught by p. Why we are using this? Because the mole fraction of benzene is to be calculated in the vapor phase. And in case of vapor phase, we use a different formula. Okay? Which is P1 chi1 is equals to P total. Okay? So this was your formula, remember? We use that formula here and we will substitute the value accordingly to get it as 0.447. Because here the mole fraction of benzene is to be calculated in the vapor phase and not in the solution phase. Any doubt in this one? So this is the total pressure and this is the pressure of P1, which is chi1 P1 naught. Any doubt in this question? Is it clear to all of you? Anyone who has a doubt, you can just comment it here. Or if you have a different answer for this, then also you can ask. Okay, I'm assuming that it is clear to all of you. So anyone who has a doubt? Please comment your doubt if you have any doubt in this question. Is it clear to all of you? Moving on to the next question. An aqueous solution of 2% weight by weight non-volatile solute exerts a pressure of 1.004 bar at the boiling point of the solvent. Okay. Now, what is the molecular mass of the solute? Now, what are the options? 0.3655, 36.55, 41.37 and 40.16. So, you are given with the weight by weight percent of the non-volatile solute and you are also given with the pressure your non-volatile solute is exerting at the boiling point. Now, how you solve it? So, the correct answer will be 41.37. First of all, what we will do is we will write the given thing. So it is given that P naught is equals to 1.013 bar. Now why we are saying it? Because we have to take the overall pressure as 1 atm. Again, let me make it clear. So this is a very good question. It is saying that your pressure at boiling point of the solvent is 1.004. So at boiling point, what will be the pressure of the pure solvent? I said it in the definition that the boiling point is that point at which the pressure of the liquid is equals to the pressure of the atmosphere or your atmospheric pressure. So if you take your pure solvent and you take your solvent to its boiling point, that at that point your pure solvent will have a vapor pressure equals to the atmospheric pressure. That is the basic definition of your boiling point. Now if that is true, then P naught will be 1.013 bar or 1 atm. Then what is the weight of the solvent? If you are taking 100 gram of it, of the solution, so it will be 98 gram. Then according to the Raoult's law, we know that P naught 1 by P1 minus P naught minus P1 by P naught is equals to W solute by M solute into M solvent by W solvent. So it is straight coming from the relative lowering of the vapor pressure. If you put all the values here, so at this temperature, which is your boiling point of the solvent, the pressure of the solution is 1.004 and your pressure of the pure solvent will be 1 atm or 1.013 bar. So if you put these values here, then here we have the weight of the solute 2. Then since it is written that it is an aqueous solution, so the molar mass of the solvent, which is your water, it will be 18. Next, we have 98 gram of the solvent. So we put it here and we have to calculate the molar mass of the solute. This will come out to be 41.37 gram per mole. Is it clear to all of you? Any doubt in this? Okay. Anyone who has a doubt in this? So I'm assuming that everyone is getting the point. Next question. Vapor pressure of pure benzene is 119 torr and that of toluene is 37.0 torr at the same temperature. Now, the mole fraction of toluene in vapor phase, which is in equilibrium with a solution of benzene and toluene having a mole fraction of 0.50 will be. So, what is given? You are given with the pure pressure, pure benzene's vapor pressure, which is P naught B, I would say 119 torr, and vapor pressure of the pure toluene, which is 37 torr. So P naught A and P naught B both are given. Next, you have to calculate the mole fraction of the toluene in the vapor phase, right? Where the solution of benzene and toluene having a mole fraction of 0.50. Okay, so toluene's mole fraction is given. It is 0.50 already. But this mole fraction that you are seeing, it is given for the solution phase and you have to calculate the mole fraction for the toluene and toluene in the vapor phase. Got it? Correct answer will be B, which is 0.237. Let us see how we will solve it. So first of all, from Raoult's law, for ideal solution we know that the total pressure will be the partial pressure of A and B. So this is from the Dalton's law of partial pressure. And from the Raoult's law, we can write PB is equals to P naught B chi B and PT is equals to P naught T chi T, where P naught B and chi B are for benzene and P naught T chi T are for toluene. Next, if you put the values here, so we know all the values. Why? Because it is given in the question that the partial pressure of, mole fraction of benzene and toluene is 0.50. Got it? And we are also given with the pure pressure of benzene and toluene, which is 119 and 37 torr. If you put all of them together, then you will get it as 78 torr. Next, we will have to calculate the mole fraction of toluene in vapor phase. So for that, we will use the formula chi T, which is the vapor pressure of toluene in the vapor phase, Okay, so chi t v is equals to P naught T chi t by P total. It's very simple. Why we are doing this? Because we know the formula for the for the mole fraction in the vapor phase, which is P of A is equals to P total into y T, where P total is the total pressure, PA is the pressure of A, and YA is the mole fraction of A. Got it? So from that we can rearrange it and write it as chi T of V, which is the mole fraction of toluene in the vapor phase, is equals to P naught T, which is the pure pressure of the pure solvent toluene, then multiplied with the mole fraction of toluene in the liquid phase divided by the total pressure. Total pressure is 78. Pressure from toluene, partial pressure from toluene is 18.5. See, we have calculated it here, and if you divide it, you will get it as 0.237. Next question. So, on mixing heptane and octane from an ideal solution to form an ideal solution at 373 Kelvin, the vapor pressure of the two liquid component, which is your heptane and octane, is 105 kilopascal and 45 kilopascal. Okay. Next, the vapor pressure of the solution obtained by mixing 25 gram of heptane and 35 gram of octane will be, you are given with the molar mass of heptane 100 gram per mole and your molar mass of octane, which is 114 gram per mole. How we will calculate it? Let's see. So the correct answer will be 72 kilopascal. Now moving on to the solution. First of all, the total pressure can be written as the partial pressure from the heptane, which is chi h into P naught h, and the partial pressure from the octane, which is P naught O into chi O. Then if you put the values here, what will happen? You can get your answer. But before that, you need to calculate the mole fraction of heptane. You are given with the mass of heptane and the molar mass of heptane. Similarly, you are given with the molar mass of octane and the mass of octane. Put it here. 25 by 100 divided by 25 by 100 plus 35 by 14, which is equals to 0.45. Now, you can calculate the mole fraction of octane by simply subtracting 0.45 from 1. You will get it as 0.55. After that, we can put it back in the first equation. So 0.45 into 105 plus 0.55 into 45. This will give your total pressure as 72 kilopascal. Okay, easy to do. So this is our last question of today's class. A binary liquid solution is prepared by mixing N-heptane and ethanol. Now, which one of the following statement is correct regarding the behavior of the solution? And this was asked in 2009. First one. The solution formed is an ideal one. Second one. The solution is non-ideal and it will show positive deviation from Raoult's law. Third one. The solution is non-ideal and it will show negative deviation from Raoult's law. And the last one. N-heptane will show positive deviation while ethanol will show negative deviation. Now think about N-heptane and ethanol. Whether they are polar, non-polar, what is their nature? So that is important here. So N-heptane is clearly a linear chain containing of carbon and hydrogen only. As a result of this, it will obviously be a non-polar molecule. Whereas if you take ethanol, which contains OH group, which is a electronegative element, it will create an polarity within the molecule. Okay, so one is polar, which is your ethanol, and the other one is non-polar, which is your N-heptane. Now it is sure that it will not form an ideal solution. In case of ideal solution, the nature of the two components are always same. Okay, so the first option is already deleted. Now question comes, which one will be the correct answer? Will it form a positive deviation or will it form a negative deviation? The answer lies in their interaction. So the answer would be that your solution will be a non-ideal and it will show a positive deviation from Raoult's law. Let's see how. First of all, as I said earlier, that the nature of the two given components are different. One is polar and the other one is non-polar. As a result of it, it will form a non-ideal solution. But what kind of non-ideal solution? So N-heptane and ethanol, since they have different kind of your nature, so they will show poor interaction between them. Okay, so if both are polar, so the interaction will be very good. But since one is polar and one is non-polar, the interaction is bad. As a result of that, the molecular interactions are less and the molecules are not closely attracted to each other. Now what will happen as a result of that? your molecules will easily leave the liquid phase and go into the vapor. So, more and more vapor will be formed. So, the vapor pressure will be increased. Therefore, you will see a higher vapor pressure than the expected one. So, what we can say, that the resulting solution will show a positive deviation from the Raoult's law. Is it clear to all of you? Any doubt till this point? So, we have covered all the parts of the solution chapter. In the next class, we will start equilibrium. So, I will suggest all of you to study a part of the equilibrium before moving on to the crash course, or you can just revise it so that we can quickly go on with the formulas only. So, if you have a doubt regarding solution, you can just post it here right now. Our math faculty will join you in a minute. Okay. So this was all for today's class. Thank you for joining the session. We will begin with our math session in few minutes.
Hello everyone. Am I audible to all of you? Am I audible to you? So, welcome to this lecture, 140 days JEE lecture series course. So, in today's lecture, we will discuss first of all permutations and combination theory. And as you know, after discussing theory, we will discuss practice questions 1 permutations and combinations. Okay, this is our disclaimer. So, first see which topic will be covered in today's lecture. Okay, so first we will talk about circular permutations. There we will see what is circular permutation and how to find number of permutations in circular permutations. Okay, and then we will discuss some important results 1 circular permutations. So there are some important results 1 circular permutations that we will talk about later. After that, we will talk about an important topic on this chapter, that is combinations. Okay, so you all know about combinations. What is combination? You all know. Okay, so combination is basically when you have n different things, okay, and you want to select r at a time, then NCR is called combination. Okay, actually you are selecting r different things from a n different things. Okay, this is combination that I will talk about in our lecture. After that, we will see some properties of NCR. So there are some important properties of NCR. We will talk about them. Next, we will see some important results 1 combinations. Okay, so there are some important results 1 combinations. These results will help you to solve many problems. Okay, so we will talk about some important results 1 combinations. After discussing these topics, we will discuss some practice questions 1 permutations and combinations. Okay, all right. So I hope you are with the notebooks and pens ready. So may I start lecture? So let's start today's lecture. So first we will discuss circular permutations. So first of all, you may ask what is circular permutations. Okay, so if we have a closed curve, okay, like a circle, you all know about circle. So if you have a closed curve and you have different objects, okay, and your motive is arrange these are different objects along a closed curve. Okay, so this type of permutation is known as circular permutation. Clear? So if different objects are arranged along a closed curve, then permutation is known as circular permutation. All right, then if we have n different things and you are taking all at a time, so and you have condition where clockwise and anti-clockwise orders are considered different. So you are not consider clockwise and anti-clockwise same, you are considering clockwise and anti-clockwise as a different direction. Okay, so that case the number of circular permutations of n different things taken all at a time is n minus 1 factorial. Why? Because when you select when you arrange n different things taken all at a time, that case you are when in this case when clockwise and anti-clockwise orders are considered different, that case first you fix things. Okay, so you first fix arrangement of one thing and then you have n minus 1 remaining things and you arrange them in n minus 1 factorial ways. Okay, so that is why the number of circular permutations of n different things taken all at a time where clockwise and anti-clockwise orders are considered different is n minus 1 factorial. I hope it's clear. Now if we consider clockwise and anti-clockwise as same, okay, that means if clockwise and anti-clockwise circular permutations are considered to be same, that case the number of circular permutations of n different things taken all at a time is n minus 1 factorial divided by 2. Why? Because here each arrangement has a mirror image. Okay, and you all know mirror images are identical. That's why we divide by 2. Clear? So if clockwise and anti-clockwise circular permutations are considered to be same, then the number of circular permutations of n different things taken all at a time is n minus 1 factorial divided by 2. Clear? I hope this is clear. Okay, now we will discuss number of circular permutations of n different things taken r at a time. So before we have taken all at a time and you have given n different things, okay, and you have taken n different things taken all at a time, okay, you want to find that case number of circular permutations of n different things, and that case you have taken all at a time. But if we find number of circular permutations of n different things, so you have n different things, and if we take it, if you have taken r at a time, then what is the number of circular permutation that we have to find? Okay, so here we have two cases. First case is when clockwise and anti-clockwise orders are taken as different. Okay, and the second case is when clockwise and anti-clockwise orders are taken as same. Okay, so in this case, we first discuss number of circular permutations of n different things taken r at a time when clockwise and anti-clockwise orders are taken as different. Okay, so first of all, you select and arrange r items in a line in NPR ways. Okay, and then divide by r. Then you will get the number of circular permutations of n different things taken r at a time when clockwise and anti-clockwise orders are taken as different. Okay, so you must focus on this point, clockwise and anti-clockwise orders. Okay, so if clockwise and anti-clockwise orders are taken as different, that case we do not need to divide by 2, but if we have clockwise and anti-clockwise orders are taken same, that case we have to divide by 2. Okay, next, when clockwise and anti-clockwise orders are not different, okay, that means when clockwise and anti-clockwise orders considered same, okay, that case we have to find the number of circular permutations of n different things. Clear? So you are finding basically circular permutations of n different things and you are taking r at a time. Okay, at a time you are taking r items from n different things. That case we have to find the number of circular permutations. Okay, so what is the circular permutations? Number of circular permutations of n different things taken r at a time when clockwise and anti-clockwise orders are not different. Okay, so this is similar as before. Okay, so in before we first select and arrange r items from n different things in a line in NPR ways. Okay, and then we divide by r. But in this case, each arrangement has a mirror image. Okay, and you know mirror images are identical, so we divide by 2. So number of circular permutations of n different things taken r at a time when clockwise and anti-clockwise orders are not different is NPR divided by 2 times r. Clear? I hope it's clear. Okay, is it clear to all of you? Do you have any doubt? Do you have any doubt on circular permutations? So I hope you all understand circular permutation. Okay, so we have studied about circular permutations. Actually, first we in circular actually when clockwise and anti-clockwise orders are considered different in a circle, that case the number of circular permutation is n minus 1 factorial. Okay, and if clockwise and anti-clockwise circular permutations are considered to be the same, then the number of circular permutation of n different things taken all at a time is n minus 1 factorial divided by 2. Okay, and then when you have taken r at a time from n different things, that case the number of circular permutations is NPR by r when clockwise and anti-clockwise orders are taken are different. Clear? And then number of circular permutations of n different things taken r at a time when clockwise and anti-clockwise orders are not different, that case the number of circular permutations is NPR divided by 2 times r. Clear? I hope it's clear to all of you. Now moving to the next. Now we will discuss some important results one circular permutations. Okay, so there are some important results one circular permutation that we will talk about now. Okay, so here first note, first results one circular permutation. Okay, so here we have m different things and n different things. Okay, where m is greater than equal to n, and what we want to do, so we want to find the number of ways in which m different things and n different things can be arranged in a circle. Okay, and we have some conditions. So in first result we have a condition, no two things of second kind come together. Okay, so we have to find the number of ways in which m different things and n different things where m is greater than equal to n can be arranged in a circle so that no two things of second kind come together. Okay, so what is the number of ways? So the number of ways is m minus 1 factorial times mpn. How we get it? Okay, so that we will discuss now. So you have m different things. Okay, so what is the circular permutation of m different things? What is the circular permutation of m different things? So the circular permutation, number of circular permutation of m different things is m minus 1 factorial. Here we consider clockwise and anti-clockwise are different. Okay, so the number of circular permutations of m different things is m minus 1 factorial. Clear? And then after finding the number of circular permutations of m different things, you have now n different things. Okay, n different things. So you have to place n different things. So how many gaps you have? So you have basically 5 m gaps. Okay, so you have m gaps and you want to take n gaps out of m gaps. Okay, so in how many ways you can place n different things in m gaps? So in m gaps you can place n different things in mpn ways. Okay, so the number of ways in which m different things and n different things where m is greater than equal to n can be arranged in a circle so that no two things of second kind come together is m minus 1 factorial times mpn. Clear? I hope it's clear. So now move to the next result. So in next result we have m different things and n different things and we have to arrange them in a circle. Okay, and we have here the conditions, so all the second type of things come together. Okay, and we have to find the number of ways in which m different things and n different things can be arranged in a circle. So how many ways we can arrange them in a circle, that we have to find. So the number of ways in which m different things and n different things can be arranged in a circle so that all the second type of things come together is factorial m times factorial n. Clear? How we obtain it? You have m different things and n different things. Okay, and here we have condition, second type of things come together. Okay, so we can treat here second type of things as a single block. Okay, so we can now treat second type of things as a single block. So now you have basically m plus 1 items. Why? Because you have m types, m different first kind of things. Okay, and second types we consider as a single block. So this consider 1. Okay, single one. So we have now m plus 1 distinct objects. Okay, distinct things. Okay, different things. So now how many number of circular permutation you get from m plus 1 different things? So the number of circular permutations of m plus 1 different things is m plus 1 minus 1 factorial. Okay, this is simply m factorial. So now you consider n different things as a single block. Okay, but inside the block you can arrange n different things in n factorial ways. Okay, so the number of ways in which m different things and n different things can be arranged in a circle so that all the second type of things come together is m factorial times n factorial. Okay, this is the final formula. for the number of ways in which m different things and n different things can be arranged in a circle, so that all the second type of things come together. Clear? I hope it's clear. Now move to the next result. So in next result we have m different things and n different things. Okay, and we have condition m is greater than or equal to n. Okay, and we have to arrange them in the form of garland. Okay, so you may ask now, what is garland? So garland is like a circle. Okay, garland is like a circle but with reflection symmetry. Okay, so this is actually garland. So you have to find the number of ways in which m different things and n different things can be arranged in the form of garland, so that no two things of second kind come together. Okay, so find the number of ways. So the number of ways is m minus 1 factorial times mpn divided by 2. Okay, how we obtain it? So you have m different things, okay, and you are arranging m different things in the form of garland. So in how many ways we can arrange it? So we can arrange them in m minus 1 factorial by 2 ways. Okay, and now you have m gaps and you want to place n different things. So in m gaps you can place n different things in mpn ways. Okay, so the number of ways in which m different things and n different things where m is greater than or equal to n can be arranged in the form of garland, so that no two things of second kind come together is m minus 1 factorial times mpn divided by 2. Clear? I hope this is clear. Now see fourth result, one circular permutation. Okay, so in fourth result we have m different things and n different things. Okay, and we have to arrange m different things and n different things in the form of garland. Okay, so that all the second type of things come together. Okay, so find the number of ways. So the number of ways is factorial m times factorial n divided by 2. Okay, this is the number of ways in which m different things and n different things can be arranged in the form of garland. Okay, so that all the second type of things come together. Okay, how we obtain? So first of all, you treat n different things as a single block. Okay, n different things we are treating as a single block. Okay, now how many different things you have? Now you have m plus 1 different things. So what is the number of circular permutation of m plus 1 different things? So the number of circular permutation of m plus 1 different things in the form of garland is m plus 1 minus 1 factorial divided by 2. Okay, that is m factorial by 2. Okay, and within the block n different things can be arranged in factorial n ways. So the number of ways in which m different things and n different things can be arranged in the form of garland, so that all the second type of things come together is factorial m times factorial n divided by 2. Okay, this is the final formula. So I hope you will understand these four important results, one circular permutations. Okay, in first one we have in a circle, when we arrange m different things and n different things where m is greater than or equal to n, and we are not taking two things of second kind come to together. Okay, that is the number of ways is m plus 1 factorial times mpn. Okay, and in second result we have m different things and n different things, and arrangement of type is circle. Okay, and the condition is second type of things come together, that is the number of ways is factorial m times factorial n. Okay, and in third result we have m different things and n different things, and where m is greater than or equal to n, and we are arranging them in the form of garland. Okay, so arrangement of type of arrangement is garland, and condition is no two things of second kind come together, that is the number of ways in which m different things and n different things can be arranged in the form of garland is factorial m minus 1 times mpn divided by 2. Okay, in fourth result we have the number of ways in which m different things and n different things can be arranged in the form of garland. So here arrangement type is garland. Okay, and you have m different things and n different things. Okay, and here we have given condition all the second type of things come together. Okay, that case the number of ways is factorial m times factorial n divided by 2. Clear? I hope these results are clear to all of you. Okay, so now moving to the next. So now we will discuss combinations. So what is combination, that we will discuss, and what is the notation of combination, that also we will discuss, and then we will discuss formula of combinations. Okay, so what means combination? So what does it mean combination? So combination means selection of things. So you have suppose 3 bags. Okay, uh, you want to select them, so that case you use combination. Okay, so combination means selection of things. So how to find combination and how to denote it? So the number of combination of n different things taken r at a time is ncr or n choose r. Okay, so it can be written as ncr or n choose r. Then see the formula of ncr. So ncr equals n choose r. This is equal to n times n minus 1 times n minus 2 times dot 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 n minus r plus 1 divided by factorial r. Okay, so here you can multiply and divide by n minus r factorial. Okay, and then you will get n factorial. How? Because n times n minus 1 times dot 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 n minus r plus 1 times n minus r factorial is nothing but factorial n. Okay, so this is equal to factorial n divided by factorial r times n minus r factorial. Okay, and you will know npr equals n factorial divided by n minus r factorial. Okay, so ncr equals npr divided by factorial r. So this is actually relation between ncr and npr. So which come first? So combination comes first. Okay, combination comes first and then permutation come. Okay, so first we select and then we arrange anything. Okay, so ncr, this is equal to npr divided by factorial r. So you can also write npr equals factorial r times ncr. Okay, this is the relation between npr and ncr. So npr equals factorial r times ncr. Okay, clear? Do you have any doubt? This is very simple. I hope you have no doubt on this slide. Okay, so here we have basically what does mean a combination. Okay, and then how to denote combination, that we have, and then we have formula of combination ncr. Okay, and then we have a relation between npr and ncr. Okay, very simple. So I hope it's clear to all of you. So now moving to the next. So now we will talk about properties of ncr. So there are some important properties of ncr that we will talk about now. Okay, so notice here the first property, ncr equals nc n minus r. Okay, that means if we choose if you have n different things and you are taken r at a time, then that is actually n choose r or ncr. Okay, and this is equivalent to if we choose n minus r items from different n items, that is nc n minus r. Okay, these are equivalent to each other. Okay, and counts of ncr and nc n minus r both are equal. So you know ncr equals factorial n divided by factorial r times n minus r factorial. Okay, you will know this formula, ncr equals factorial n divided by factorial r times n minus r factorial. Okay, and then nc n minus r equals factorial n divided by n minus r factorial times n minus n plus r factorial. This is equal to n factorial divided by n minus r factorial times r factorial. Okay, so these two quantities are equal. Okay, the ncr is equivalent to nc n minus r, hence proved. Now look at second property of ncr. So in second property of ncr we have ncx equals ncy. Okay, so when you have two binomial coefficient, okay, like ncx and ncy, and we say they are equal, then that case it implies x equals y or x plus y equals n. Okay, so if ncx equals ncy, then x equals y or x plus y equals n. Okay, so either x equals y or x plus y equals n. For example, suppose you have 6c2, okay, and you have 6c4. Okay, so is they are equal? Is they equal? Is 6c4 and 6c2 equal? Give your answer in chat section. Okay, so is 6c2 equals 64? Can you prove it? Do you have any idea about this? NC 6c2 and 64. Okay, first count 6c2 using NCR equals factorial n divided by factorial r times n minus r factorial. Okay, and then find 6c4. Okay, and compare them. Is they equal or not? Okay, so you can count 6c2. 6c2 is what? 6c2 equals factorial 6 divided by factorial 2 times 6 minus 2 factorial. Okay, so you can calculate it, and 6c4 equals factorial 6 divided by factorial 4 times 6 minus 4 factorial. Okay, both are equal. Okay, so you can say 6c2 and 6c4 are equal. Why equal there? Because you can see here, if we compare with ncx and ncy, okay, so ncx equals ncy, it implies x equals y or x plus y equals n. Okay, so 6c2 equals 64 because 2 plus 4 equals 6. That means x here 2 and y equals 4 and n here 6. So 2 plus 4 equals 6. So it satisfied. So 6c2 equals 6c4. Clear? I hope it's clear. Now let's look at third property of NCR. Okay, so in third property of NCR, we have NCR plus NCR minus 1 equals n plus 1 CR. Okay, what does mean it? So here from start from RHS. Okay, so n plus 1 CR means what? You are choosing R items. Okay, you have n plus 1 different things and you have taken R at a time. Okay, this means n plus 1 CR. This is equivalent to NCR plus NCR minus 1. That means if you have n different things and if you want to take R items, then that is NCR, and you have n different things and you want to take R minus 1, that is NCR minus 1. So if you add them, then you will get n plus 1 CR. Okay, that means you have n plus 1 different things and taken R at a time is equivalent to this is actually equivalent to NCR plus NCR minus 1. Okay, so NCR means you are choosing R different R objects from n different things. Okay, this is equivalent to if you choose R minus 1, if you choose R minus 1 items, okay, from n different things, okay, if you add them, then you will get n plus 1 CR. Clear? I hope you understand. Okay, and note here these three properties of NCR. Okay, first property is NCR equals NCN minus R. Second property is NCX equals NCY. It implies x equals y or x plus y equals n. Okay, and the third property is NCR plus NCR minus 1 equals n plus 1 CR. Clear? So you should focus on these properties of NCR. These are very important properties and these are very useful properties. Okay, in the point of view of JEE. Clear? So you should keep in your mind these properties of NCR. Clear? I hope these are clear to all of you. So now moving to the next. Now we will discuss some important results 1 combinations. Okay, so there are some important results 1 combinations that we will discuss now. So first property, you have n different things and you are taking R at a time. When p particular things values occur, okay, so what is the number of combination that we have to find. Okay, so you have n different things, okay, and you have taken r at a time. And here we have given condition p particular things will always occur, means p particular things will always included. Okay, so p particular things always included, so it the number of selection is basically 1 for p particular things. Okay, and now you have remaining n minus p different things. Okay, and now you have to choose r minus p things. Okay, so now you have to just find the number of combinations of n minus p things taken r minus p at a time. Okay, so just you have to select r minus p things from n minus p different things. Okay, this is the number of combinations of n different things taken r at a time when p particular things will always included. Clear? Then see a second property, second result, one combination. Okay, so here we have n different things and taken r at a time when p particular things things never occur. Okay, that means we are not taking p particular things. Okay, so p particular things are forbidden, so you have to find the number of combinations. Clear? So p particular things never occur means p particular things are forbidden, so just you have remaining n minus p different things. Okay, and you are taking r at a time, so in how many ways we can take r different art items from n minus p different things. So the number of combinations of n different things taken r at a time when p particular things never occur is n minus p cr. Okay, this is the formula, this is the final formula for the number of combinations of n different things taken r at a time when p particular things never included. Clear? I hope it's clear. Okay, now see the third result one combination. So in third result of combination we have to select of 0 or more things out of n different things. Okay, so what is the number of selections of 0 or more things out of n different things, that we have to find. Okay, so you have choice, you can select or not. Okay, so you have two choices for that. So you have like n things. Okay, so total number of choices is 2 to the power n, and you will know 2 to the power n is equivalent to the binomial expansion nc0 plus nc1 plus dot 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 plus ncn. Okay, so the number of selections of 0 or more things out of n different things is nc0 plus nc1 plus dot 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 plus ncn equals 2 to the power n. Clear? I hope it's clear. Okay, this is very simple. Just you have to keep in your mind this formula nc0 plus nc1 plus dot 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 plus ncn equals 2 to the power n. Next, see fourth result on combinations. Okay, so here we have to select one or more things out of n different things. Okay, so what is the number of selections of one or more things out of n different things, that we have to find. So the number of selections of one or more things out of n different things is 2 to the power n minus 1. Okay, so you are not selecting here empty empty thing. Okay, empty collection. Okay, that means you started from 1. Okay, and you are taking one or more things, so out of n different things, so the number of selections is 2 to the power n minus 1. Okay, and 2 to the power n minus 1 is equal to the binomial expansion nc1 plus nc2 plus dot 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 plus ncn. Okay, so just you have to keep in your mind this formula nc1 plus nc2 plus dot 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 plus ncn equals 2 to the power n minus 1. Okay, this is the number of selections of one or more things out of n different things. Okay, very important and very useful formula. Okay, then fifth result one combination. Okay, so you have 0 or more things out of n identical things. Okay, you have to you have to find the number of selections of 0 or more things out of n identical things. Okay, so you have n identical things, so you can choose 0, 1, 2, 3 up to n. Okay, so how many number of selections are there? So the number of selections of 0 or more things out of n identical things, you have n plus 1. It started from 0 and ended at n. Okay, so 0, 1, 2, 3 up to n, you have n plus 1 number of selections of 0 or more things out of n identical things. Clear? And the sixth result one combination, the number of selections of one or more things out of n identical things is n. Okay, here you can choose 1, 2, 3, 4 up to n. Okay, so you have n number of selections of one or more things out of n identical things. Then see here, seventh result one combination. Okay, so you have p plus q plus r things. Okay, so you have p plus q plus r things, and where p are alike of one kind, q are alike of second kind, and rest are alike of the third kind. Okay, and what you have to do, you have to find the number of selections of one or more things from p plus q plus r things. Okay, so what is the number of selections of one or more things from p plus q plus r things? So you have p are alike of one kind. So in how many ways you can select p are alike of one kind? Okay, so you have you have choice of 0, 1, 2, 3 up to p. So you have p plus 1 choices for first kind. Okay, and for the second kind you have q plus 1 choices, and for the third kind you have r plus 1 choices. Okay, so you have to just now multiply them, and here you have to subtract 1, because here you are finding the number of selections of one or more things. Okay, so you have to subtract the selection that where we select nothing. Okay, so the number of selections of one or more things from p plus q plus r things where p are alike of one kind, q are alike of the second kind, and the rest are alike of the third kind is p plus 1 times q plus 1 times r plus 1 minus 1. Clear? I hope it's clear. So do you have any doubt? So you can ask, otherwise we will move to the next. Okay, so now see, eighth number important result one combination. Okay, so you have p identical things of one kind, q identical things of second kind, and r identical things of third kind. Okay, and you have n different things. Clear? So you have to find the number of selections of one or more things from p identical things of one kind, q identical things of second kind, and r identical things of third kind. Okay, and you have n different things. So how many number of selections you will get? So the number of selections of one or more things from p identical things of one kind, q identical things of second kind, and r identical things of third kind, and n different things is p plus 1 times q plus 1 times r plus 1 times 2 to the power n minus 1. Okay, so you can see here you have p identical things of one kind. So you can choose in p plus 1 ways, and you have q identical things of second kind, you can choose it q plus 1 ways, and you have r identical things of third kind, so you can choose it r plus 1 ways. Okay, and you have n different things, so you can select this and not. So you have two choices for that. So you have total choices 2 to the power n. So now just multiply them. So p plus 1 times q plus 1 times r plus 1 times 2 to the power n. Okay, and here subtract 1, because you actually subtracting 0 things. Okay, selecting of 0 things. Okay, so the number of selections of one or more things from p identical things of one kind, q identical things of second kind, and r identical things of third kind, and n different things is p plus 1 times q plus 1 times r plus 1 times 2 to the power n minus 1. Clear? This is the final formula. Now see ninth number result. Okay, so in ninth number result we have there are m items of one kind, n items of another kind, and so on. Okay, so then we have to find the number of ways of choosing r items out of these items equal coefficients of x to the power r. Okay, so you have m items of one kind, so you have choices 0, 1, 2, 3, 4 up to n. m. Okay, and for n items you have 0, 1, 2, 3 up to n, and so on. So for 0 uh 0 items you have coefficient of x is x to the power 0. For one item you have x to the power 1 coefficient of x to the power 1, and then for two items you have x square. Okay, so you have this polynomial 1 plus x square plus dot 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 plus x to the power m. Okay, and so on. And then for n items, so that case you have the polynomial 1 plus x square plus dot 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 plus x to the power n. Okay, and you will go like this. So then multiply, then you will get the number of ways of choosing r items out of these items equal coefficient of x to the power r. So the answer is 1 plus x squared plus dot 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 plus x to the power m times 1 plus x squared plus dot 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 plus x to the power n, and dot 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 and so on. And see now 10th result one combination. So if there are m items of one kind, n items of another kind, and so on, okay, then we have to find the number of ways of choosing r items out of these items such that at least one item of each kind is included in every selection equal coefficient of x to the power r. So in how many number of ways we will get? So the number of ways of choosing r items out of these items such that at least one item of each kind is included. Okay, at least one item, so we cannot take here 0 item. So it's the polynomial for m items, that is x plus x squared plus dot 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 plus x to the power m. For n items you have the polynomial x plus x squared plus dot dot plus x to the power n. Okay, and so on. So the number of ways of choosing r items out of these items such that at least one item of each kind is included in every selection equal coefficient of x to the power r in x plus x squared plus dot 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 plus x to the power m times x plus x squared plus dot 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 plus x to the power n times dot 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 and so on. Clear? I hope it's clear to all of you. Now we will start practice questions. Okay. So student, let's look at question number 1 here. Okay, so in this question we have to find the number of integers greater than 6000. Okay, and you have digits 3, 5, 6, 7 and 8, and here you have to note this point without repetition. So the repetition is not allowed. So we have to find the number of integers greater than 6000 that can be formed using the digits 3, 5, 6, 7 and 8. Okay, so here we have four options. Among these four options, which option is correct, that you have to find. So first of all, try it by yourself, and after that see the solution. Clear? So try it. Everyone try it. Which option is correct? Take your time and try it. Give your answer. Which one is correct? Quickly do it. Very simple. Easily can do. So what you have to do? you have to find in number of integers greater than 6000. Okay, so I'm giving you hint. Okay, so you will get here two case. Okay, case 1, there you will take for you will take 4 digits. Okay, and the second case is you will take 5 digits number. Clear? So because you have 5 digits, so you can take a 4 digits number, and you can take 5 digits number. So you will have two cases. Case 1, you can take 4 digits numbers, and the case 2, you can take 5 digits numbers. Okay, and I also want to give you another hint, that is here you have to find the integers greater than 6000. Okay, so for first place, for first place, for 5 digits numbers, 4 digit numbers. Okay, for 4 digit numbers, the for the first place you have choice 6, 7 and 8. Okay, so try it. Everyone give your answer in chat section. Hurry up. Are you trying? Everyone give your answer. Almost I said you what you have to do. I have given you hints. Okay, so using that hints, try to do it yourself first. Okay, otherwise you will not learn how to solve question. Everyone try it. Okay, so now we will solve this question. So everyone match with your answer. Here the correct answer is option B. Okay, so option B is the correct answer for this question. So let's start the solution step by step. So you have to find the number of integers greater than 6000 by using the digits 3, 5, 6, 7 and 8. Okay, so here we have two cases. Okay, case 1, when number is of 4 digit. Okay, so you can take 4 digit number, that is our first case. So for 4 digit number can start from 6, 7 or 8. So first for first digit of 4 digit number, you have 3 choices. Okay, you may take 6 or 7 or 8. Thus the total number of 4 digit numbers which are greater than 6000 is basically, for first digit you have 3 choices, for the second digit you have 4 choices. Okay, and for the third digit you have 3 choices, and for the fourth digit you have 2 choices. Okay, so total number of 4 digit number which are greater than 6000 is 3 times 4 times 3 times 2, and if we multiply them, then you will get 72. Okay, this is the total number of 4 digit number, okay, which are greater than 6000. Clear? Now see case 2. So we may take 5 digit. Okay, so when number is of 5 digit, that case what will happen, that we will see. So total number of 5 digit number which are greater than 6000 is nothing but factorial 5. Okay, you will know what is factorial 5. So factorial 5 is 120. So the total number of 5 digit number which are greater than 6000 equals 120. So in case 1 we found total number of 4 digit number which are greater than 6000 is 72. Okay, and in case 2 we found total number of 5 digit number which are greater than 6000 is 120. Okay, now add these two cases and get the total number of integers greater than 6000. Okay, so therefore total number of integers is 72 plus 120. Okay, if you add them, then you will get 192. Okay, this is the total number of integers. Clear? I hope it's clear. So you can see, you can visualize here for 4 digit number. For first digit you have choices 6, 7 or 8. Okay, for you have 3 choices. Clear? For second digit you have 4 choices. For the third digit you have 3 choices, and for the fourth digit you have 2 choices. Okay, you have total choices 3 into 4 into 3 into 2, that is 72. So the total number of 4 digit number which are greater than 6000 is 72. Clear? I hope it's clear to all of you. So if you have any doubt, so you can freely ask here. Do you have any doubt? I hope it's clear. Okay, now moving to the next. So what we have to do in this question, so we have to find the number of 5 digits telephone numbers having at least one of their digits repeated. Okay, so you have here 4 options. So among these 4 options, which option is correct, that you have to find. So first of all, try it by yourself and then see solution. Okay students, so first of all, try it. Everyone try it. Take your time and try it, and give your answer in chat section. Please do it. Very simple question. Okay, you all can do it. Very simple. So I'm giving you a hint. So you can find total number of 5 digit telephone numbers. Okay, then you have to find no digits repeated. Okay, for that case, find the number of 5 digit telephone numbers. Okay, then you have to subtract where no digits repeated, okay, from the total number of telephone numbers. Okay, do it. Which option is correct? Please give your answer in chat section. Everyone do it. Right? Yes, you can do. Very simple. You can do it. And write your option. Which option is correct? You can write in chat section. Please write in chat section. Everyone do it. And give your answer in chat section. Very simple question. Very easy. Okay. Which option is correct? Here. Write your answer. Quickly give answer. Very simple question. It will not take much time. Very simple. Okay. So what do you have? You have in option A 90,000. In option B you have 1 lakh. In option C you have 30,240. In option D you have 69,760. So which option is correct among these 4 options? Please write your answer in chat section. Okay, I hope you try to solve this question. So now we will see which option is correct, and then we will solve it step by step. So our correct answer is option D. So match with your answer. Okay, here correct answer is option D. So now let's start the solution step by step. So focus 1 here. So you have 10 digits 0, 1, 2, 3 up to 9. Okay, so using the digits 0, 1, 2, 3 up to 9, you have to find the number of 5 digits telephone numbers which can be formed. Okay, so at least one of their digits repeated, that we have to find. Okay, so first find using the digits 0, 1, 2, 3 up to 9, number of 5 digit telephone numbers which can be formed is 10 to the 5. Here repetition is allowed, so here you can repeat any digits. Okay, so you have 10 to the 5 number of 5 digits telephone numbers by using the digits 0, 1, 2, 3 up to 9. Clear? Now find the number of 5 digit telephone numbers which have none of the digits repeated. Okay, so here you have to find number of 5 digits telephone numbers which have none of the digits. Okay, you have no digits will be repeat. Okay, so what will be the number of 5 digit telephone numbers which have none of the digits repeated? That is basically you have to select and then arrange. Okay, so 5 digits from 10. Okay, 10 different digits. Okay, that is 10 p5 ways. So the number of 5 digits telephone numbers which have none of the digits repeated is 10 p5. Okay, and if we use now NPR formula, that is n factorial divided by factorial r times n minus r factorial. Okay, so if you use this formula, then you can easily find the value of 10 p5. Okay, so 10 p5 equals basically 10 factorial divided by 10 minus 5 factorial. Okay, this is simply equals 10 factorial divided by 5 factorial. Okay, so if you now simplify further, then you will get the number of 5 digit telephone numbers which have none of the digits repeated is 30,240. Okay, this is the number of 5 digit telephone numbers which have none of the digits repeated. Clear? And what now we have to find? We have to find the number of 5 digit telephone numbers having at least one of the digits repeated. Okay, so what we have to do, basically we have to subtract the number of 5 digit telephone numbers which have none of the digits repeated from the number of 5 digits telephone numbers which can be formed using the digits 0, 1, 2, 3 up to 9. Okay, that is 10 to the 5. Okay, therefore the required number of telephone number is 10 to the 5 minus 30,240. Okay, so if we calculate it, then you will get the number 69,760. Okay, right? All right, so the required number of telephone number is 69,760. This is the final answer. Clear? So the number of 5 digits telephone numbers having at least one of their digits repeated is 69,760. Clear? I hope it's clear to all of you. Okay, now moving to the next. So in this question we have the word small. Okay, so what we have to do, we have to we have to find the position of the word small. Okay, so if all the words with or without meaning, okay, having 5 letters. Clear? So if all the words having meaning or not having 5 letters formed using the letters of the word small, and if we arrange them as in the dictionary order, then we have to find the position of the word small. Okay, so which here we have given 4 options. So which option is correct, that you have to find. So first of all, try it by yourself and then see solution. Okay, so take your time, everyone try it. Everyone try it, do it, take your time and do it. And give your answer in chat section. Which option is correct? Everyone. Very simple question. You can do it. Do it. And write your answer in chat section. Which option is correct? Please do it. Everyone do it. Which option is correct? And write your answer in chat section. Hurry up. You are all brilliant students. I know you all can do it. Give your answer in chat section. Okay. So now we will see which option is correct, and then we will see how we obtain that option. Okay. So our correct answer is option D. So please match with your answer. Okay, here the correct answer is option D. Let's start the solution step by step. So clearly you can see number of words start with A is factorial 4 divided by factorial 2. Okay, this is 12. And number of words start with L is factorial 4. Okay, and this is equals 24. And number of words start with M is factorial 4 divided by factorial 2 equals 12. And number of words start with SA equals factorial 3 divided by factorial 2 equals 3. And number of words start with SL equals factorial 3 equals 6. Now note that next word will be small. Okay, so just add 12, 24, 12, 3 and 6, and then you will get the next word small. So now find the position of the word small. So the position of the word small is 58. Okay, hence the position of the word small is 58, and here our correct answer is option D. So I hope you understand, okay, all the steps. And further, if you have any doubt, then you can ask here freely. Okay, I think you understand it. Okay, it's clear to all of you. Now moving to the next. Here in this question, we have to find the total number of permutations of n which is greater than 1 different things taken not more than r at a time, when each thing may be repeated any number of times. Okay, so you have here 4 options. So among these 4 options, which option is correct, that you have to find. So first understand what wanted to say this question. Okay, and then write your answer in chat section. So try it by yourself now. First, everyone do it. Try it. Please do it and write your answer in chat section. Everyone, quickly. Very simple question. You can do it. Are you trying? Which option is correct? Okay, so let's see now the correct option, and let's solve this question step by step. The correct answer is option C. So match with the answer. Okay, so here the correct answer is option C. Now let's start the solution step by step. So first note here, when we arrange things one at a time, then the number of possible permutation is what? N. Okay, and when we arrange them two at a time, then the number of possible permutations are n times n, that is n squared. Okay, and so on. So what will be the total number of permutations? So the total number of permutations are n plus n squared plus dot 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 plus n to the power r. So this is actually geometric progression with first term n and common ratio n. Okay, so easily you can find the sum of this geometric progression. So what is the sum of this geometric progression? The sum of this geometric progression is, if you have geometric progression ar squared. Okay, so a plus ar squared plus dot dot plus ar to the power n. The sum of this geometric progression is a times r to the power n minus 1 divided by r minus 1 when r is greater than 1. Okay, so since here n is greater than 1, so the sum of n squared and dot 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 n to the power r is n times n to the power r minus 1 divided by n minus 1. Okay, this is the total number of permutations. Clear? Thus the total number of permutations are n plus n squared plus dot 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 plus n to the power r equals n times n to the power r minus 1 divided by n minus 1, since n is greater than 1. Clear? Well, right, I hope it's clear. Okay, very simple. Okay, you easily understand what we have done here. Okay, so first we arrange things one at a time. So that case the number of possible permutation is n, and after that we arrange them two at a time. Then that case the number of possible permutations are n times n equals n squared. Okay, and so on. That then we added them n squared and dot dot n to the power r, and then we'll get the total number of permutations. Okay, and then just we use very basic concept of geometric progression. Okay, GP, sum of geometric progression, and we get the answer n times n to the power r minus 1 divided by n minus 1, since n is greater than 1. Here the correct answer is option C. So now moving to the next. So in this question we have these equations: npr minus 1 divided by a equals npr divided by b equals npr plus 1 divided by c. Okay, and then you have four options, so you have to choose which option is correct. Okay, so you have to choose the correct answer from the given four options. So how can you do it? So first take n two quantities, npr minus 1 divided by a and npr divided by b. Okay, and then take second and third and simplify them, you will get the answer. Okay, you will get the relation between a, b and c. So first of all, try it by yourself. Take your time and do it by yourself first. Everyone do it. Please everyone do it and write your answer in chat section. Very simple question. You can do it. You just have to use a definition of npr. Okay, and just you have to do algebraic manipulation and you will get the answer. Okay, do it. Everyone do it. Which option? Which option? Right? Okay, take your time and do it. Everyone do it. Okay, let's see the solution. Our correct answer is option A. Okay, so students, match with the answer. Okay, here the correct answer is option A. Let's start the solution step by step. So since NPR minus 1 divided by A equals NPR divided by B equals NPR plus 1 divided by C. First take first two terms. Okay, so from first two terms you will get n factorial divided by n minus r plus 1 factorial divided by A equals n factorial divided by n minus r factorial divided by B. Now let's simplify it. Then you will get B upon A equals n minus r plus 1. Okay, note this equation. B upon A equals n minus r plus 1. Now from last two terms, n factorial divided by n minus r factorial divided by B equals n factorial divided by n minus r minus 1 factorial divided by C. And after simplifying, you will get this equation C by B equals n minus r. Okay, so C by B equals n minus 1. Note this equation also. Now by comparing both equations, you will get B upon A equals C upon B plus 1. Okay, now let's simplify it. So if you simplify it, then you will get B squared equals A times B plus C. Okay, this is the final final answer. Okay, so you can understand it, and very simple solution. Just we do calculation. Okay, and then after calculation we compare them, obtain equation, and then we get the relation of A, B and C. Okay, so I hope you understand and it's clear to all of you. So now moving to the next. Here in this question we have to find the range of the function f of x equals 7 minus x p x minus 3. Okay, and you have given here 4 options, so you have to choose the correct answer from the given option. So first of all, try it by yourself and then see solution. So everyone do it. Just here use a definition of NPR. Okay, and you have to use relation, okay, between them, and you'll get the domain of this function. And after getting domain, you can easily find the values of the function f of x at that points, and you will get the range of the function. Okay, so try it yourself first. Everyone do it. Take your time and do it. Okay, and give your answer in chat section. Please do it. Please do it, everyone. Easy question, very easy question. Okay, everyone do it and give your answer in chat section. Good. So let's see the solution. Our correct answer is option A. Let's start the solution. We have given that f of x equals 7 minus x p x minus 3. Okay, and the above function is defined if 7 minus x is greater than equal to 0 and x minus 3 is greater than equal to 0, and 7 minus x should be greater than equal to x minus 3. Okay, now solve this inequality and get the values of x. Okay, so here it implies x is less than equal to 7, x is greater than equal to 3, and x is less than equal to 5. So easily you can find the domain of this function f. So domain of function f is basically 3, 4, 5. Now find f of 3. So f of 3 is 4p0. This is equals 1. And f of 4 equals 3p1. This is equals 3. And f of 5 equals 2p2. This is equals 2. Okay. Therefore, the range of the function f is set 1, 2, 3. This is the final answer. Very simple. Clear? I hope it's clear to all of you. So now moving to the next. In this question we have the word triangle. Okay, and here we have given condition no vowels are together, and we have to find the number of different words that can be formed from the letters of the word triangle so that no vowels are together. So find the number of different words. So we have given a 4 options, so you have to choose the correct answer from the given options. So everyone try it by yourself and then see solution. Take your time, try it. Everyone do it and give your answer in chat section. Please do it. Please do it, everyone, and give your answer chat section. Yes, you can do it. Which option? Give. Okay, see the solution. The correct answer is option C. So match your answer with this answer. Okay, here the correct answer is option C. Let's start the solution. So in a word triangle, you have A E I as a vowels and G L N R T as a consonants. Okay. So first fix the 5 consonants in alternate position. So in how many ways you can fix 5 consonants in the alternate position? That is 5 factorial ways. Okay. So you can see here we fixed 5 consonants in alternate position in 5 factorial ways. In rest of the 6 blank position, you have 6 blank position and you have to select 3 vowels. Okay. So in rest of 6 blank position, 3 vowels can be arranged in 6p3 ways. Therefore, total number of different words is basically 5 factorial times 6p3. Okay, so now simplify it. So 5 factorial is 120 and 6p3 is 6 into 5 into 4. Okay, so total number of different words is 120 times 6 into 5 into 4. This is equal to 14,400. Okay, this is the final answer. So I hope it's understand. Okay, very easy. You can easily understand it and it's clear to all of you. So what we have to first we fix our 5 consonants in alternate position in 5 factorial ways, and then in the rest of the 6 blank position 3 vowels can be arranged in 6p3 ways. Then we multiply them and we get the total number of different words. Okay, and after multiplying we get the answer 14,400. Okay, this is the final answer. Clear? That's all for today's lecture. Thank you for your attention. I hope this lesson was helpful to all of you. Hello everyone. In today's lecture, we are going to learn about gravitation, and this is theory part 1. Alright, this is our disclaimer. So, firstly, we will see trend analysis of the chapter gravitation in JEE main exam. So, according to last 5 years, the overall weightage of this chapter in the examination, it is 4.49%. Alright, and if we talk about the yearly question distribution, so we can say in 2024 question asked from acceleration due to gravity, number of questions 1. And if we talk about difficulty level, so we can say question was average. Similarly, in 2023 question asked from escape velocity, number of questions 1, and their difficulty level, we can say question was easy. In 2022 question asked from gravitational potential energy, number of questions 1, and their difficulty level average. Similarly, in 2021 question asked from universal law of gravitation, earth satellites. Alright, and in this year question and total number of question is 3. 2 question was average and 1 question was easy. Alright, so this is most important concept. And in 2020 question asked from variation in acceleration due to gravity, and number of questions 1, and their difficulty level average. Alright, so from this data we can say the important concepts are acceleration due to gravity, escape velocity, gravitational potential energy, universal law of gravitation, earth satellites, variation in acceleration due to gravity. Alright, so these are the important concepts. In today's lecture, we will cover first gravitation, then we will discuss universal law of gravitation. After that, we will discuss acceleration due to gravity. Then variation in G with altitude and depth with respect to Earth. Alright. Then we will discuss variation in the value of G due to the rotation of the Earth. Then gravitational field. Then gravitational field intensity. And then we will discuss gravitational potential. After that, relation between gravitational field and gravitational potential. So these are the topics of the today's lecture, which we will discuss one by one. Alright everyone. So the first topic is our universal law of gravitation. If we talk about the statement, so we can say in this universe each body, or we can say every body, attracts other body with a force, and that force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So to understand the universal law of gravitational, we have a mathematical relation. So according to universal law of gravitation, every body, alright, or we can say each body attracts other body with a force. So that force is here capital F. Alright, and that force is directly proportional of product of masses, their masses. So one body having mass capital M, second body having mass small m. Alright, and the distance between the body, it should be r square. Okay, r, and after squaring, so the relation we can say, or we can say the formula to calculate the force between two bodies, that is F equal to G into M, capital M, into small m divided by r square. Alright everyone, so this is the universal law of gravitation. The important point here, please note down everyone. Uh, this force this force law is valid for point masses. For extended bodies, there is a different method to find this force. Alright. Now, if we talk about the symbols, constant and their SI unit and dimensional formula. So we can say here capital G is the proportionality constant denoted by capital G, okay, and this proportionality constant is known as universal gravitational constant. In SI system, value of gravitational constant capital G is 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. Alright, so this is the unit and this is most important for the exam. And if we talk about the dimensional formula, so we can say the dimensional formula of G is m inverse L cube T raised to the power minus 2. Alright everyone, I hope universal law of gravitation is clear. Yes or no? Clear everyone? Shivam? Alright. The next topic is acceleration due to gravity. The acceleration of an object during its free fall towards the earth is called acceleration due to gravity. Alright. So look at here. Suppose we have a pen. Alright. And when we dropped a pen like this. So this is the free fall condition. Alright. Why? Because due to gravity, the force have been under free fall condition. The gravity attracts towards the surface of the earth. Okay, so here we have a look at figure, we have a small mass m on the okay, and r is the radius and c is the this one is the center. So if m is the mass of the earth and r is the radius, the earth attracts a mass m, small m, alright, on the surface, on its surface with a force capital F. So you know universal law of gravitation. So the expression will be F equal to G into m divided by r square. Here capital M is the mass of the earth and small m is the mass of the body, right, that is attracted by gravity towards the earth, surface of the earth, and r is the radius of the earth. Alright. This force imparts an acceleration to the mass m, which is known as acceleration due to gravity small g. So according to Newton's second law, we can say acceleration is equal to force upon mass, and we know the value of force. Think about it, that is g m into m divided by r square and divided by small m. So when we is performing calculation, so small m cancel out, the remaining term is acceleration small g is equal to g into capital M divided by r square. Okay. So on the surface of the earth, small g equal to capital G into small capital M divided by r square.
and mass of the earth is 6 into 10 raised to the power 24 kilogram, and the radius of the earth 6.4 into 10 raised to the power 6 meter. So when we substituting the value of G, M, R in the above relation, alright, so you will be get the value of small g, that is 9.8 meter per second square. Alright everyone? Alright. Now the next concept is variation in g with altitude and depth with respect to earth. So the value of small g is a variable. It means what? It means the value of small g is vary. If vary with altitude, vary with depth. So in some cases, as mentioned below. So first we can say value of acceleration due to gravity at a height h from the surface of the earth is given by g prime equal to g into r square divided by r plus h whole square. Alright. So now if small h is less than r, okay, this is our first case. So in that case what will be the change in the formula? So then the formula will be g prime equal to small g into 1 minus 2h divided by capital R. Alright. So this is valid for acceleration due to gravity at a height h. Now value of acceleration due to gravity at a depth d from the surface of the earth. The formula will be g prime equal to g multiply with 1 minus d divided by capital R. Alright. So here one special case, and that is at the center of the earth. It means what? It means small d is equal to r, and so then in that case we can say g prime equal to 0. Okay everyone? Yes or no? Clear? Now let's discuss the variation in the value of acceleration due to gravity g due to earth rotation. So here uh, we can say that due to rotation of the earth, alright, the value of g decreases as the speed of the rotation of the earth increases. So the value of acceleration due to gravity at latitude is g prime lambda is equal to g minus r omega square cos square lambda. Alright, here r is the earth's radius, omega is the earth's angular velocity, which is its rotational speed. And think about it, lambda, what is this? So following conclusions can be drawn from the above discussion, and we will also talk about the lambda here. So A, the effect of the centrifugal force due to the earth's rotation. Okay, so we can say effect of centrifugal force due to rotation of the earth is to reduced to the effective value of small g. Second, effective value of g is not actually in the vertical direction as we seen here in the figure. So at the equators, so lambda equal to 0 degree, yes or no? So we can say g prime equal to g minus r omega square. This is the minimum value. And at the poles, lambda equal to 90 degree. Therefore, g prime equal to g, and this is maximum. Alright. So this becomes our maximum value. And this formula is very important. G prime lambda is equal to g minus r omega square cos square lambda. Alright everyone. Now we will talk about the gravitational field. So here question arises, what is field? In electrostatics we already discussed electrostatic field. All right, and what is that? So we can say a field in which a charge feel an electrical effect. Yes or no? So similarly, if we talk about the gravitational field, so we can say the space surrounding a material body in which its gravitational force of attraction can be experienced is called its gravitational field. All right. So, so look at figure. Suppose we have here we have a body having mass small m. So the force, or we can say field, experienced by this body around the space surrounding by a, look at here, space surrounding by a surrounding a material body. So the field here is gravitational field. Next concept is gravitational field intensity. All right. Any doubt here? Yes or no? Tell me if you have any doubt. All right. So next is gravitational field intensity. So how we can define gravitational field intensity? Basically, gravitational field intensity at any point is defined as the force experienced by any test mass divided by magnitude of the test mass when placed at the desired point. So mathematically, the gravitational field intensity I equal to force upon m naught, where m naught is a small text mass and the SI unit of gravitational field intensity is Newton per kg. Okay. Now if we have a point mass in, then at a radial distance r from that mass, the gravitational field intensity will be I equal to gm divided by r square. And if there is a solid sphere with mass capital M and the radius capital R at a distance r from its center, which is outside of the sphere. Okay, outside sphere means small r is greater than capital R. Okay, the gravitational field intensity I equal to gm divided by r square. And at the surface of the solid sphere, in that case I equal to gm divided by r square. Listen carefully, here both r is different. Small r is the radial distance and capital R is the what? Radius of the earth. Okay. Okay everyone. So if this point lies inside this sphere, it means what? It means radial distance is less than radius of the earth. So r is small, r is less than capital R. So then its formula here will be I equal to g m r divided by r cube, meaning that inside this sphere the value of this field increases linearly. So from this it can be concluded that at a zero radial distance gravitational field intensity will be 0. Okay. So let's see graphically. So if we observe the variation of gravitational field intensity with respect to radial distance small r for a solid sphere, then its plot will be appears as follows. Okay, so look at here. If we talk about the inside, listen carefully, inside this sphere intensity is directly proportional to radial distance r. Okay, and this is linear. And if we talk about the outside this sphere, so in that case it is inversely proportional to radial distance square. It means what? It means I is inversely proportional to r square. So if I equal to on the surface, and on the surface of the solid sphere I equal to gm divided by r square. So here this line parallel to y axis shows the on the surface, that is a gm divided by r square, and inside the surface r is less than r, so I is directly proportional to r, and outside it means r is greater than radius of the radius of the solid sphere, so I is inversely proportional to r square. Okay, so this is the graphical representation, I versus radial distance. Now we will discuss the gravitational field intensity due to a cell. So due to a body in the form of uniform cell, gravitational field intensity at a point outside the cell. Again here the point is outside the cell. It means small r is greater than radius of the body, and that is the cell here. So the formula will be I equal to gm divided by r square. But if we talk about the gravitational field intensity at any point inside the cell, then the inside the cell the gravitational field intensity will be 0. Gravitational field intensity follows the superposition principle. Okay, this means that if we need to find the net intensity at a particular point due to several masses, then it will be the vector sum of all of them. Why? Because gravitational field intensity is a vector quantity. Okay everyone, thus I equal to I1 plus I2 plus I3 and so. Gravitational potential. So if we talk about the gravitational potential, so we can say gravitational potential at any point in a gravitational field is defined as the work done in bringing a unit mass from infinity to that point. Okay, in simple words we can say the work you do to bring a unit mass from infinity to a particular point will become the gravitational potential of that point. So to calculate the gravitational potential we have a formula, V equal to limit m naught approaches 0 w upon m naught. So gravitational potential due to a point mass is given by V equal to minus gm divided by small r, where small r is the radial distance from the mass m. And gravitational potential is always negative. Okay, if we talk about the nature, so we can say gravitational effect is always attractive in nature. It is a scalar term, and if we talk about the SI unit, so the SI unit is joule per kg. Okay, clear everyone? So now we will look at the gravitational potential due to a solid sphere at a different points inside, outside and on the sphere. So listen carefully. If we talk about the inside, it means the point P lies inside the cell, like look like here. And if we talk about the center, so then point P lies at here. And if we talk about outside, the point will be here. Okay, so we have a 3 cases: inside, outside and on the solid sphere. So first case, outside the sphere. So that is for outside, it means small r is greater than radius of the solid sphere. So the potential will be V equal to minus gm divided by r. And at a point on the surface, so V equal to minus gm divided by r. And at a point inside the sphere, so small r is less than r, So in that case, V equal to minus gm divided by 2r cube into 3r square minus r square. So when we performing this calculation, you will be get V equal to minus gm divided by 2r multiply with 3 minus r square divided by r square. Okay, small r is the radial distance and capital R is the radius of the solid sphere. So we have a formula V equal to minus gm divided by 2r into 3 minus r square by r square. So at the center of the solid sphere, so in that case what? So we can say r equal to r, yes or no? Small r is equal to capital R. So V equal to minus 3 into gm divided by 2r. So when we solving this, you will be get 3 by 2 into V surface. Okay, which means that at the center of the sphere the potential is 3 by 2 times that of the surface potential value. I hope this is clear. Okay, okay students. Now gravitational potential. So gravitational potential due to a spherical cell. Okay, again here we will discuss three cases. So in first case, at a point outside the cell. Outside the cell means small r is greater than small r is greater than radius of the spherical cell. So potential will be a minus gm divided by small r. And at a point on the surface of the spherical cell, V equal to minus g into capital M divided by capital R. Okay. And at any point inside the spherical cell, so V equal to what? So inside the spherical cell, the potential will be equal to minus gm divided by r. That is equal to potential at the surface. Okay. Now relation between gravitational field and gravitational potential. So if R1, look at here, if R1 and R2 are the position of 2 points in the gravitational field with intensity capital I, then we can write the change in gravitational potential. So that is V of 2 equal to minus V of n equal to minus integration R1 to R2 I dot dr. So this is very important. So dv equal to, we know, minus I dot dr. Here dr is dx I cap plus dy j cap plus dz k cap, elementary displacement, and I equal to ix I cap plus iy j cap plus iz k cap. So if we want to calculate dv, and that is equal to minus I dot dr, so it will be dv equal to minus ix dx minus iy dy minus iz dz. Okay. Thus we can write I equal to minus del v upon del x I cap minus del v upon del y j cap minus del v upon del z k cap. Here x component of gravitation field intensity will be given as Ix is equal to minus del v upon del x. This means to find the x component of gravitation field intensity, we need to differentiate gravitational potential V with respect to x, assuming y and z constants. Okay. Similarly, to find the y component of gravitational field intensity, we need to differentiate potential V with respect to y and assuming x and z as a constant. Okay. And if we talk about the z coordinate, so we can say if we need to differentiate potential V with respect to z assuming x and y as a constant. Okay. Okay everyone. So today we learned about gravitation, that is the universal force of attraction, between masses responsible for the motion of celestial bodies and the structure of the universe. Then we discussed a universal law of gravitation that states that every mass attracts every other mass with a force directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. And acceleration due to gravity, the acceleration experienced by an object uh, due to earth gravitational pull approximately 9.81 meter per second square at the surface. And variation in g with altitude and depth, the value of g decreases with altitude, increased distance from the earth center, and also decreases with depth due to the reduction in mass above. And variation of g due to earth's rotation. So here we can see the centrifugal force due to the earth rotation slightly reduces the effective value of g at the equator compared to the poles. Then we discussed uh, gravitational field, a region around a mass where other masses experience a force. It is a field that represents the gravitational influence of an object. Then gravitational field intensity I, the force per unit mass experienced by a small test mass placed in the field. So I equal to Fym. Then gravitational potential, the work done in bringing a unit mass from infinity to a point in the gravitational field, typically negative due to the attractive nature of gravity. Then relation between gravitational field and gravitational potential, that is I equal to minus dB upon dr. Alright, thank you for your attention. Now students, we will discuss, or we can say we will solve some practice questions based on gravitation. So I hope, are you ready for the practice questions? Yes or no? Uh, if yes, write in the chat box. Clear? Hello students. Now we will discuss some practice questions based on gravitation, and this is part 1. This is our disclaimer. So here we will discuss some practice questions based on gravitation. So our first question, listen carefully. A mass capital M is split into two parts, small m and capital M minus small m, which are separated by a certain distance. It should be or it could be, we can say r1 r2, anything separated by a certain distance. So the ratio small m divided by capital M, which maximize the gravitational force between the parts, is what? So given options, option A 1:4, option B 1:3, and option C 1:2, and option D 1:1. So which option is correct? Let's try to solve this question. Here question says find the ratio of small m divided by capital M, which maximize the gravitational force between the parts. Yes, please solve this question. Which one is correct? VK, Varsha? Good. VK, good. So correct option is 1:2. Now we will see the solution. So to find out the force between two bodies, or we can say gravitational force between two bodies, the formula is F equal to G into capital M into small m divided by R square. Okay. So in this question, uh, the magnitude of gravitational force between two bodies is F equal to G into small m into capital M minus small m divided by x square. Here small m is the mass of the parts and the remaining mass is capital M minus small m divided by x square. Okay. So this is the magnitude term. Okay everyone. Now question says that maximize the gravitational force. It means what? So for maximize and for a maximum gravitational force, we will differentiate this force with respect to mass small m and put equals to 0, and the term after the calculation we will solve. So when we differentiate f with respect to small m, so it will be df upon dm is equal to g divided by x square m minus 2m. So this is the differentiation of the above equation after the uh, or we can say differentiation of the above equation. Okay. So now we will put it equals to 0. So 0 equal to g divided by x square m minus 2m. So now we solving this expression. So when we solving this expression, so here uh, small m divided by capital M is equal to 1 by 2. Okay. This means we can say the ratio of masses should be 1:2. Okay. Okay everyone. Clear? Yes or no? Now let's see next question. Two particles of mass 2m and 2 into capital M, alright, small m and capital M are respectively at points A, B and C with AB equal to 1 by 2 into BC. Okay. So at A the mass is 2 into capital M, at B mass is small m, and at C mass is capital M. Okay. Now the important point here is this: small m is the much smaller than capital M, and at time t equal to 0 they are all at rest as given in the figure. Okay. So then choose the correct statement. So the statement is option A, m will remain at rest, Option B, M will move towards the capital M. Option C, M will move towards 2 into capital M. And option D, M will have oscillatory motion. So which option is correct? Think about it and please try to solve this question, everyone. Yes. All right. Anyone? Varsha? Karthik? Good VK. Anyone? Yes. Varsha? Which one is correct? Yeah. Let's see the solution. So correct option is C. M, small m will move towards 2 into capital M. It means what? It means this small m moves towards the B2A. Okay. So let's see the solution. So the particle small m, this one, will move towards the greater force between the forces by 2m and capital M. So the small m is situated between 2m and capital M. So the magnitude of force on small m due to 2 into capital M will be G into 2m into m divided by AV square. Yes or no? You know the formula of universal law of gravitation, F equal to G into mass of the body, here gap 2m, and the other mass is small m, and divided by distance between them. So that is here AB. So we can write AB square. Okay. So this is the force, or we can say magnitude of the force on small m. And if we talk about the direction, so direction will be towards B to A. Okay. And magnitude of force on small m, this one, due to capital M. So again we will use the formula of universal law of gravitation, that is force is equal to G into capital M into small m divided by distance square. So here is capital M, it means mass of the body, and another mass is small m, and divided by distance between the bodies. So what will be the distance here? B to C. Okay, BC. So we can say BC square. And if we talk about the direction, so direction is will be towards B to C. Okay, mass will move towards the greater force between forces. So here the greater mass is capital M. So according to question, as it is given that BC equal to 2 times of AV. Okay, so just put the value of BC and just put the value of AB. All right. So we know force on M due to capital M is equal to Gm into M divided by 2 into AB whole square. So it is equal to Gm into M divided by 4 into AB square. Why? Look at here, AB is equal to what? Here BC equal to what? BC equal to this one. BC equal to 2 times AB. So just put the value of here 2 times AB. So when we solving this equation, you will get GM into capital M into small m, and the square of 2 is 4, and it will be remaining terms is AB square. So the force will be this one. This means gravitational force due to mass 2m is larger as compared to mass capital M. Therefore, the mass m will move towards the mass 2m. Okay? Yes, VK, your answer is correct. Good. Anyone? All right. Now, third one, if one moves from the surface of the earth to the moon, what will be the effect on its weight? Okay, the options are: A, weight of a person decreases continuously with height from the surface of the earth. Option B, weight of a person increases with height from the surface of the earth. And option C, weight of a person first decreases with height and then increases with height from the surface of the earth. And option D, weight of a person first increases with height and then decreases with height from the surface of the earth. So read question carefully and think about it. So which option is correct? Okay, what will be the effect on its weight? All right, everyone, please try to solve this question. Yes, this is theoretical question. So the correct option is C. Weight of a person first decreases with height and then increases with height from the surface of the earth. Okay. Let's see the solution. So as a person moves away from the surface of the earth, it means what? It means their distance from the earth center increases. Okay. So the gravitational pull from the earth decreases, as we know universal law of gravitation, F equal to g m mass of the body into mass of the another body divided by square of the distance between them. All right. So however, as they get closer to the moon, in that case gravitational pull from the moon increases. So the weight of the person is the net gravitational force from both the earth and the moon. So at some point between the earth and the moon, gravitational forces from both celestial bodies will cancel each other out and the person will be weightless. Now next case is started here. So after this point, the gravitational force from the moon becomes dominant and the person's weight starts increasing again as they get closer to the moon surface. Okay. So first decreases with height, then increases. Next one, at the surface of a certain planet, acceleration due to gravity is 1/4 of that on the earth. If a brass ball is transported on this planet, then which of the following statement is not correct? Given options: option A, the brass ball has same mass on the other planet as on the earth. Option B, The mass of the brass ball on this planet is a quarter of its mass as measured on the earth. And option C, the weight of the brass ball on this planet is a quarter of the weight as measured on the earth. And option D, the brass ball has same volume on the other planet as on the earth. So which option is correct? And please solve this question. This is also a theoretical question. Yes. B. Okay. Anyone? Let's see the solution. So correct option is B. Alright. The mass of the brass ball on this planet is a quarter of its mass as measured on the earth. Let's see the solution. So the mass of an object is a fundamental property, okay, that measures the amount of matter it contains. This is the definition. It does not change when location or gravitational force vary, okay. So therefore a brass ball will have the same mass on another planet as it does on the earth. Thus, weight of an object, however, is the force of gravity acting on its mass, calculated by the formula W equal to mg, where W is weight and small m is the mass and g is the acceleration due to gravity. So, acceleration due to gravity on the other planet is 1/4 of that on the earth, and the weight of the brass will be 1/4 of its weight on the earth. Therefore, the incorrect statement is that the mass of the brass ball is a quarter of its mass on the earth. Okay. Next one. If if both the mass and radius of the earth decreases by 50%, the acceleration due to gravity would be what? Option A, remains same. Option B, decreases by 50%. Option C, decrease by 100%, and option D, increase by 100%. So tell me which option is correct, A, B, C or D. Yes, please try to solve this question, everyone. Yes, Varsha, VK, Arthik, Shivam, anyone? All right, good. Anyone? So correct option is D. increase by 100%. So we know the formula, acceleration due to gravity on the surface of the earth. So small g is given by the formula small g equal to gm divided by r square, where capital G is the universal gravitation constant and capital M is the mass of the earth and capital R is the radius of the earth. Alright. So problem states that the mass and radius is decreased by 50%. This means the new mass m prime and new radius r prime will be m prime equal to 0.50 m and r prime equal to 0.50 r. Okay. So substitute the new mass and new radius into the formula for the acceleration due to gravity and we will get new acceleration, that is g prime. So g prime is equal to g into m by 2 divided by r by 2 whole square. When we solving this, so you will be get 2 into capital G into small capital M divided by r square. Now look at here, this one, this is the small g. So we can say g prime, new acceleration g prime is equal to 2 into old acceleration, that is small g. So g prime equal to 2g. So in terms of percentage, so we can say percentage increasing equal to g prime minus g divided by g into 100%. So we know the value of g prime. So g prime is 2g. So just put here minus g and divide by g into 100%. So when we performing this calculation, we will get percentage increasing equal to 100%. 2g minus g and g divided by g 1 and 1 into 100%. Alright everyone. Okay. A research satellite of mass 200 kilogram circles on circles of the earth in an orbit of average radius 3r divided by 2, where capital R is the radius of the earth. Assuming the gravitational pull on a mass of 1 kilogram on the earth's surface to be 10 Newton, the pull on the satellite will be what? Given options: option A 880 Newton, option B 889 Newton, option C 885 Newton and option D 892 Newton. Okay, so which option is correct? Please solve this question and tell me the answer. So correct option is 889 Newton. Alright. So we know mg equal to 10. So we can say 1 into g equal to 10. So value of small g is equal to 10 meter per second square. So variation of acceleration due to gravity at radial distance r outside the earth from the center of the earth is given by the relation, that is small g prime equal to g into r square divided by r square. So we know the value of g, that is 10 meter per second square. So g prime equal to g 10 into r square divided by 3 by 2 divided by 2 3r by 2 whole square equal to 40 by 9 when we solving. So force on the satellite will be what? That is m prime g prime. So or we can say force equal to this value of m prime is 200 into g prime is 40 by 9. So when we performing this calculation, you will be get force is equal to 889 Newton. Alright. So therefore force or pull on the satellite will be 889 Newton. So the correct option is B. Alright everyone. The height from the surface of earth at which the acceleration due to gravity becomes g by 9, where g is the acceleration due to gravity on the surface of the earth, in terms of r is what? Given options: option A 2r, option B r by root 3, option C r by 2, and option D root 2 into r. So which option is correct? Please try to solve this question. Which one is correct? All right, anyone? Okay, let's see the correct option. So we can say correct option is 2r. So we know the formula to calculating acceleration due to gravity at height h is g prime equal to gm divided by r plus h whole square. Okay, so the given that acceleration due to gravity becomes g by 9, so just replace g prime here, it will be g upon 9 equal to gm divided by r square into r square divided by r plus h whole square. So when we performing this calculation, you will be get g by 9 equal to g into r plus r divided by r plus h whole square. It means 1 by 9 equal to r divided by r plus h whole square. So r divided by r plus h is equal to 1 by 3. It means 3r equal to r plus h. So the relationship between h and r, it will be h equal to 2r. So the required height h from the surface of the earth will be 2r. Okay. The change in the value of small g at a height h above the surface of the earth is the same as at a depth d. Okay, it means the value of g at height h and at depth d both will be same. Okay, when both d and h are much smaller than the radius of the earth, then which of the following is correct? Given options: option A d equal to h upon 2r, option B d equal to 3h upon 2, option C d equal to 2h, and option D d equal to h. So which relation is correct? Think about it and please try to solve this question, everyone. You need to just find out the correct relation. Okay, so correct option is D. Correct option is C, d equal to 2h. Let's see the solution. So we know the formula to calculate the acceleration due to gravity at height h from the surface of the earth, that is gh is equal to g into 1 minus 2h divided by r. Yes or no? So let this is equation first. And acceleration due to gravity at a depth d below the surface of the earth, the formula is gd equal to g into 1 minus d by r. Okay. So as the statement of the problem, g at a height h above the surface of the earth is same as at a depth d below the surface of the earth. So we can say gh equal to gd. So just put the value gh and gd and solve it. So gg cancel out. So the remaining terms is 2h equal to d. So the correct relation is d equal to what? d equal to 2h. Okay, this is our correct option answer. Average density of the earth is what? Given option. uh, Average density of the earth does not depend on g, is a complex function of g, is directly proportional to g, is inversely proportional to g. So which one is correct option? Please try to solve this question, everyone. Here you have to find out the relation between average density of the earth and g. Okay, okay, anyone? So the correct option is C. Good, VK, your option is correct. Is directly proportional to G. So we know G equal to Gm divided by R square. So mass of the earth can be written as m equal to 4 by 3 pi r cube into rho. So G equal to 4 G divided by 3 into pi r cube divided by r square into rho. So rho equal to 3 divided by 4 pi g r into g. In terms of rho, the value is this one. So from this relation, listen carefully, from this relation it is clear that rho is directly proportional to g. Yes or no? Where rho is the average density of the earth. So we can see C option is correct, and the density of earth is directly proportional to the gravity g. Okay everyone? Yes or no? Any doubt? Alright. Next one. The variation of acceleration due to gravity g with distance d from the center of the earth is best represented by which figure? So there is a 4 figures and you have to find out the best representation g versus r. Okay, so which one is correct? A, B, C or D? This is a very simple question. Yes or no? So please try to solve this question, everyone. Here on y-axis acceleration due to gravity, and on x-axis r. Okay, so the correct option is C. Let's see. The variation of acceleration due to gravity, that is small g with distance d from the center of the earth, is described by two different formulas depending on whether the distance is inside or outside the earth. Okay, so first case we can say for a distance d, okay, inside the earth, it means what? D is less than equal to r, less than to r inside, okay, inside the earth, less than 2 radius of the earth. So the acceleration due to gravity is directly proportional to the distance from the center. So look at here, from origin to this point, it is linear graph, directly proportional. Okay, so the formula is g equal to gm divided by r cube into d. So here g is directly proportional to d. Yes or no? Now if we talk about the outside, so we can say g equal to gm divided by d square. So from this relation it is clear that acceleration due to gravity is inversely proportional to d square. So look at here, from this is the inversely proportional graph. So inside it is directly proportional, so graph will be linear, and outside the graph is inversely, so we can say the graph g is inversely proportional to d square, so graph will be exponentially decay like. Okay, any doubt? Yes or no? VK, Varsha, Karthik, Shibam, any doubt here? This is direct formula based graph. So if you know the formula, it will be easy for you to plot the graph. Okay. So till the Earth's surface g increases linearly with distance r as shown in the figure C. Okay everyone? Any doubt? If you have any doubt, please ask. So these are the important concepts questions. Varsha, any doubt? Okay, VK. All right. Thank you. Thank you for your attention, everyone. So that's all for the today. In next class, we will learn gravitation part 2, and we will also solve some more practice questions that improves your preparation, and you will achieve more marks in the examination, and due to these practice questions your problem solving skills will be built up. Okay, okay everyone. Clear? Yes or no? If yes, write in the chat box thumbs up. All right, thank you for your attention. Thank you. Bye bye, tata.